مش مبين حتى بايه مش مبين. طيب مين اللي تبع الاي تي هي؟
تمام؟ تمام نحكي مباشرة أستاذ. السلام عليكم. Good day for everybody. I would like to present our speaker, Mr. Mohammed Saleh. He is an independent consultant from the Republic of Yemen. His affiliation, organization, and occupational safety and health. And please, Mr. Mohammed, you have 15 minutes for your presentation. Please go ahead.
دكتور محمد تفضل.
مهندس ابراهيم.
مهندس يعقوب.
مهندس ابراهيم في مستر جيرمان هو على الاتنديز مش على الباناليست.
هاي ندحوا له باناليست، بس احنا نبلش مع الدكتور محمد.
Please, Mr. Shahab Mohammed. Let me introduce Mr. Shahab Mohammed. Shahab Mohammed. Please, you have 15 minutes for your presentation. Please go ahead. Okay. Assalamu alaikum, Mr. Mohammed. Are you with me? Can you hear me? Hello? Can you hear me, Mr. Mohammed? Mohammed, Mr. Mohammed? Mohammed Shihab, can you hear me? All right. I would like to introduce our next speaker, Mr. German Antonio Luna Mejaes. I hope I will pronounce your name correctly. Are you with me, Mr. German? Can you hear me? Mr. German.
Okay, yes, can you hear me?
Mr. German, can you hear me?
Yes, Mr. German.
Yes.
We hear you very clearly.
All right.
Okay, perfect.
Let me introduce our next speaker, Mr. German Antonio Luna Mejaes. His affiliation from Canada, Lupatec Limited, Canada. He is a chemical engineer from Simon Bolivar University in Venezuela. More than 35 years of experience in oil and gas in Venezuela and Canada. He has a passion for safety, and in the last 12 years, process safety has been his main focus. I hope I pronounce your name correctly, Mr. German. You have 15 minutes of your presentation. Please go ahead. Mr. German, are you with me?
Okay, I don't hear you that clear, but I guess that I'm ready to go.
All right. Mr. German, you have 15 minutes for your presentation, and I read your biography for our audience, and please have 15 minutes and go ahead, please.
Okay. Okay, can you see my presentation now?
Yes. We can hear you and we can see your presentation. You can start, Mr. German. Okay?
I hear a lot of echo, so could you please confirm when I can start?
Yes, you can start. We can hear you. You can start, Mr. German.
Mr. Ibrahim.
We can hear you. You go ahead. Present your presentation, please. Can you hear me?
Mr. Ibrahim?
Mr. German, can you hear me? I think we have technical problems. Let's wait for a while. Mr. German, can you hear me?
Yes, with echo, but yes, now I can hear you better.
All right. You have 15 minutes for your presentation, and you can start right now, okay?
Because we have hybrid, maybe we have not virtual, it's hybrid. I will call him by phone. Just one minute.
All right. You can go ahead, please.
Mr. German, you can start your presentation, please.
Okay, thank you. Well, good morning, everyone. My name is German Luna Mejias. I work for Lupatech in Canada. We are a company that we are specialized in process safety, troubleshooting, and training. And today I want to talk to you about one of the things that I think is critical in process safety, which is called complacency, because this is our worst enemy and can be a recipe for disaster. Before I move into the specific topics, let's quickly chat about, just one second, this is, okay, now it's working. There are two types of safety topics that we have to always check, which is occupational health and safety, which is related just to the people, not to the processes. And then process safety, which is related to events that happen in a plant, in a facility, that can affect, of course, people, environment, and business, but are not directly related to like a fall or trip or things like that. It's more of the process affecting the rest of the systems. So we're going to focus on the process safety part of it. And I always like to start with example of an iceberg. An iceberg have 1/8 of the volume above surface and 7/8 below surface. And this is what we see in real life, but many times in process safety, we want only to see what is above surface. And this is a problem because if you remember, more than 100 years ago, we have a catastrophic event because we didn't pay attention of what was below surface. And I use always this example because what we want to see, it may not be what is really there. So that's why it's important that not to be complacent, but pay attention to all the details. I have another example here that I want to share with you. One mice is well prepared, or at least somehow prepared, and the other is not. But the one on the right is thinking he's able to make it, but most likely it will fail. The one on the left may be okay. Sometimes we human, we act as the mouse on the right. Oh, I'm gonna make it. Nothing is gonna happen to me. And this is where we move in the complacency situation here. Let me give you another example. If we use a risk matrix, and this, somehow we can simplify this as a traffic light. So we may be in the red area, so we are in the wrong spot, and we try to do something to move to the left. In this case, the mouse on the right is not protected or unprotected, and the mouse on the left is protected, or there is some mitigation. So this is what we try to do when we are doing a process hazard analysis, moving from the unmitigated to the mitigated area. But sometimes we don't follow the rules. Let me give you an example from the process point of view now. Let's say that we have a column, a distillation column here, and let's assume that this valve FCV1 for some reason malfunction closed. This is the reflux. And if that happened, the pressure is gonna go up to the maximum allowing working pressure of the equipment. And it's possible that you have a failure there because you are exceeding the maximum allowing working pressure. Of course, in this scenario, on purpose, I didn't put a PSP. When we have a PSV, the game changes because even if that valve closes and the pressure, as you see in the graph here, goes up, the PSV will open and then reduce the pressure so you don't exceed the maximum allowing working pressure. So the probability of having a failure is less likely. Okay? And there are some rules for PSPs as indicated by the ASME code A Division 1 and also by API Standard 521 that we can allow some extra pressure accumulation in a vessel based on the type of protection that you use. And as a summary of this table, pretty much if you exceed the 30% of the maximum allowing working pressure, you are gonna exceed the regulation and the failure is likely to happen. So now we are going deeper into the potential problem of complacency if we run a vessel at a higher pressure than the 30% that we're talking about. We can be in catastrophic failure likelihood. Before we continue with this, let's talk about another concept that is very important, a layer of protection analysis. Layer of protection analysis is a qualitative or semi-quantitative method to make sure that our safeguards are okay. I like to say it in a plain English like that. Our safeguards are okay. I know that there will be another paper later that it's very interesting because it will talk about how good the safeguards are. They are gonna talk about low powers. So let's take the example I just showed you 3 slides before. And we have, let's say that we have an initiating event of a valve failure with a probability of 0.1. And let's assume that that consequence is a leak or rupture of the vessel. There may be a fire and there is a fatality, and I call it severity 4. And according with my example, the acceptable risk is 10 to the minus 4 in this example. So we have the initiating event and we have the acceptable risk. We have to close that gap. And this is what is called necessary risk reduction. And this is what we try to do with the LOPA. There is a gap that we have to close. To close that gap, we can use the safeguards and we can use the modifiers. And modifiers are parameters that can be used to increase or decrease the likelihood or the exposure time. Let's continue with the example. Let's say that we have people in the area 10% of the time. It's an assumption that some companies use it. Let's use in this example. So if I consider that the people is only 10% of the time in the area, I have some risk reduction, but I still have a gap. But if I install a PSB, let's assume this is a clean service, now I cover that gap. So that means that my PSB is a key component in this equation. Now is where we start with the complacency. According with this table that was provided to me by an EPC, if the pressure is between 1 and 1.3 of the maximum allowing working pressure, we should have no problem. And that's pretty much what API and ASME say. But they said that if the pressure goes between 1.3 and 2, we're gonna have just a leak, not a catastrophic failure. And they continue. If it's from 2 to 2.5, the probability is 1%. If the pressure is from 2.5 to 3, is 10%, and above 3 times the pressure is gonna be a catastrophic failure. If we use these factors in our previous graph, 1%, we place this 1% here with this overpressure modifier. As you can see here, the PSB doesn't make in this equation. It's not gonna make it in the list of critical equipment. It's not gonna be recalculated or check the size or resizes if it's a new project. Maybe the history of failure is not reviewed because we don't need it. So pretty much, if we are using these factors, we ignore the PSB, and that's where the complacency is taking place. So is this
5 minutes remaining?
Okay, thank you. So in the example of the mice, the one on the left is very likely to not make the commitment and get the cheese because it's not protected. But we humans, sometimes we say, we are gonna make it. Don't worry, keep going. And this is what I want to raise here as a concern, that when we are doing this analysis in process safety, we have to be very careful of using these factors because that can be a complacency. Another thing that is problematic with this table is that people use this factor of 1 for leaks. And I've been in many LOPAs and HASOP when the people think that a leak is just a garden hose that is leaking. But unfortunately, I have to share with the audience that this picture here is a picture of an accident that happened because of a leak. That happened close to 10 years ago because a leak that was not controlled. So saying that it's not a problem because it's only a leak is complacency. In the HASOP I was when this factor were used, I hear many times, it's not a big deal, nothing is gonna happen. And most of you that work in process safety, I'm 100% sure that you have heard that many times. But it's not true, it's a big deal. If happens, plant facility or people may be gone. And all this because of the money, they want to save some money. But a new PSB, it costs way less than $10,000. And I put here some examples of accidents that the costs associated with the rebuild or people or equipment. And just to take the last two that happened only a few years ago, the HF alkylation in Philadelphia, $750 million, and the FCC in Superior, Wisconsin, $650 million. So, as a conclusion of my study is that first, that there are no rules from ASME code, neither API standard that allowed for additional pressure protection based on vessel design and construction material. So we cannot go beyond 1.3. And of course, and I show you the picture, a leak in a process plant, depending on the operating conditions, can produce disastrous effects. Using these third-party guidelines, the guidelines I showed you, the pressure above 2 or 3, if you don't do it correctly, it's complacency. You're putting a factor to make it your LOPA easy without thinking deeper in the risk. Another thing that happens when you use this factor is that you put the severity lower, and at the same time you use these factors to close the gap in the LOPA and don't do it properly, so you can get in quicksands. My recommendation, don't use these pressure factors. It gives you a false sensation of safety, and then you may be in trouble. And also ensure that the HAZOP and LOPA facilitation is managed by a well-trained facilitator with proper process knowledge, so they can provide a good guidance to team members. Thank you so much, and your questions are welcome. If we have time, perfect. If we don't have time, my email is there. You can send me later any question if you have.
Okay.
I'd like to thank Mr. German for the valuable presentation. We'll move to the next presentations or papers with that's name. It's process safety near misses are warning sign for the major incident. It's my pleasure to introduce Dr. Rajendra Dihaya from USA. He is the professional process safety engineer, senior technical service manager, loss prevention, global services, which is one of the company, a member company for the American International Group.
If you allow me,
Rajendra and Dihaya, the floor is yours.
Mhandas Yaqub, can you hear me? We need some questions. Some people are asking Mr. German for a few questions. Can you allow us for that?
Thank you, Mohammed.
We have time, just a minute.
Can you share your presentation?
No, Yaqub.
Can you see it now?
Yeah, clear. Thank you very much.
Oh, that's great. And can you hear me?
Yeah, very clear.
That's great. So, yeah, thank you very much, German. It was a great presentation, and definitely I will be continuing from there, and I support that. It is 3 a.m. in the Houston now. So as Mohammed said, I'm Rajendra Dihaya, professional process safety engineer and senior tech service manager here in AIG. Spent 23 years in oil and gas industries in Saudi, in Kuwait, and Canada, now in US, studied in India. So I have visited almost 80 or 90 sites here in North America doing audits for insurance. So I will share my experience over here. Yeah. See that. Okay. Now, my presentation is focused on the importance of process safety near-miss investigation in preventing major incidents. I will talk about a case study and see how the gaps are identified and they will be taken care of. So if you look here, I will say, why do we keep repeating major incidents? A number of investigations of major incidents discovered that each showed several warning signs before occurring. And most importantly, all incidents were preventable. What German has highlighted, there are some of them. And the purpose of this presentation is to discuss why the warning signs were ignored and why preventable incidents were not prevented. I will explain in a case study. Let's see, what are the foremost causes of past incidents? Now, the first one is management failure to identify the hazards and or mitigate the risk of hazardous processes or chemicals. It's a pretty high level, but it's the root cause. And the process starts early in the project stage and continues throughout the life cycle of the facility. For example, a poorly done hazard study like HAZID or BHA or LOPA is one of the leading causes of this failure. Even if this step is done correctly, then what happens? The management, second cause is management failure to maintain the integrity of critical safety systems and equipment what we install. This is pretty common I have seen in the field. In the majority of the incidents, safety barriers or safeguards, whatever you call it, were either bypassed or disabled or not maintained due to inadequate management programs and or poor process safety culture. This we will discuss in the case study too. And the third cause is management failure to learn or to apply from the past incidents, the learnings. Memory is short. The focus of this presentation is on this one. So let's say, what are process safety near misses? A process safety near miss is an event that presents an opportunity to learn valuable information that may prevent future incidents without the accompanying severe consequences of a true process safety incident. These incidents are warning signs, weak signals, or precursor of a high potential incident. Commonly considered process safety near miss by API as well as leading industries are safe operating limit excursions like operations upsets. Activation of a safety system is also considered as a process safety near miss. One of them, safety system failure on demand or safety system failures during tests like pre-pop test or PSVs or SIS testing. If they fail, they should not just be fixed, they should be investigated why it failed during test, because next time it may fail during actual requirement. And there may be some other company requirement. So let's look at why to investigate process safety near misses. As discussed earlier, near misses incidents are the precursors of a high potential incident. And you have seen those, they are visible every time once they happen. Since there is no loss, if you look at here, on the pictures, it is showing the early warning signs and the weaknesses in the management program, human performance, or process safety culture. The picture depicts when the weakness or holes in management programs align the incident, or you may see different type of switches here I put together. Since there is no loss, if you see during the near miss incident, in most cases the root cause can be rectified with minimal resources such as adding or modifying hardware, improved procedures and training, improving the preventive maintenance, inspection and testing, etc. German indicated it very nicely. Less than $10,000 the PSV, hundreds of $millions for the loss. So these events are leading indicators. So an implementation of finding is a proactive approach for loss prevention. It is not a reactive approach. But if you think safety is expensive, you have heard this name, try an accident. Incident costs a lot of money, and not only in damage to plant, in claims for injuries, but also in the loss of company's reputation. The following case study will discuss more in this one. So this is a case study what I did. This is one of my clients. I cannot disclose the name. This is what happened. A safe operating limit excursions, operations upset. Process reactor is a runaway reaction hazard. I walked into the control room and saw the red window on the DCS, as you see on the picture here on the right. And I asked the DCS operator, what's going on here? That's what he told me. The last week, the process temperature reached at 372 degree Fahrenheit, 17 degree Fahrenheit above its trip point as 355, which was set. The board operator controlled the process without unit shutdown or any incident. The trip system was disabled for more than 7 years. So the unit did not trip automatically. This was the third incident in 1 year in this shift. The operation was not sure what is wrong with this case and why it is an incident. When there is no loss, it means no relevant. This incident was near the company or investigation. The company very confident about the case. So let's look at the consequences and the rest of this particular mistake. Since there are alleged consequences, the incident was going to the board at this time and clear. Potential consequences of this various are seen. Let's see what can go wrong in this experiment. The next time, there is a likelihood that the system may not be controlled and work back to the state of the unit. You several reasons, such as operators, alarm failure, or control system failure, or malfunction. The figure on the right shows how the holes are aligned and causing an incident. In this case, an explosion and fire. Based on the potential consequences, the management is operating the reactor at a very high and unacceptable risk. German showed the gaps very nicely. Considering the repeat excursions, a runaway reaction is highly likely with severe consequences. So there is a big gap. I looked at some of the management system causes. This is my own investigation, and I looked at the different areas of this one, the different departments. Let's see what caused this safeguards, why it was disabled for 7 years. There was no documentation for bypassing or disabling this critical barrier, such as safety bypass or management of change, which is required. Under the process safety, this was not captured during last 2 PHA revalidations in 7 years. This is one of the highest consequence scenario and must be well evaluated. The gap is big. This may be a candidate for a more detailed risk study such as LOPA or QRA. No PHA procedure was there, so the PHA quality was low. The process safety near miss reporting is not included in the incident investigation procedure. If you go down to maintenance, you see here there were several opportunities to capture this. Maintenance could not capture it during the preventive maintenance and testing of this critical system, safety system in 7 years. Safety critical equipment list doesn't exist. So there may be more inactive safeguards or unmitigated risk like this. Under operations, emergency operating procedures, recertification and annual operator training could have captured it. They do it every year and every 3 years. This critical safeguard must be documented in each log or shift log until returned back to service. There a checkbox approach still prevails. So if you see here, all these management programs fail to detect this bypassed or disabled safeguard.
Dr. Gender, 5 minutes remaining for this presentation, please.
Okay. Program audit or KPIs could have raised the alarm of a repeat incident. Both were checkboxed. So let's look at the culture and competency. We keep talking about competency and culture a lot. No one was aware of this change. Also, no one questioned this red window. Many managers were walking in the control room for 7 years. Nobody questioned why the window is red. A well-management program and competent, you see the picture here, competent employees and positive process safety culture are the foundation of safer workplace, as shown in the figure here. I think the analysis in last 4 slides provide you adequate takeaway to review and improve your management programs. I will not go in too much detail into this one because of the time, but let's look at this, the 5 steps investigation process. I will talk more on the first 2 or 3 is the most important over here. The first foremost step is to report an incident. Only then there can be an investigation. Good practice is to define a process safety near miss with the reporting requirement and well communicated to the people that you are supposed to report this. The second step is incident investigation. This is critical step in the investigation process where incident is categorized for its level of investigation depending on the consequence. Learning fails when near misses are investigated based on the actual consequences because there is nothing. And learning is successful when near misses are investigated for potential consequences using detailed technique by trained people and identify the root causes and fix them. In this case, the potential consequence of the incident is a disaster, but no actual consequences here. Hence, the incident was not even realized or considered. Without discovering the root cause, the recurrence of incident cannot be prevented. The omission is one of the major causes of learning failure. Now, I'll talk about the recommendations a lot. Sometimes what happens, if you get to the root cause, the recommendation doesn't address the root cause. The simple recommendation is written and say, retrain employees and do those things. And it is taken very lightly and the incident is closed. So sometimes they don't match. And even if they match, the action is closed by something else and not exactly meeting the intent of the recommendations. So I will talk more on this learning process in the next slide here. The learning in many companies I have seen is limited to incident investigation and closing the action at the plant level. There are multinational companies in different countries. Learning will be more effective if embedded into corporate policies, engineering and design standards, and operating management system. It is critical that to identify and eliminate the communication and implementation gaps in these processes and systems. So I have a detailed paper on this one, so more details are provided in the paper. if you see these particular table, I put together some of the operating or management systems programs where you can incorporate the requirement of reporting and investigating process safety near misses. The path forward. Now, the conduct gap analysis, refer to paper for more details, as I said. Define process safety near miss incident as per API 754 or past industry practices. Incorporating the management programs. It should be fixed into, it should be documented in incident investigation, operations documents, inspection and maintenance documents. Update tools, training, audits, and KPIs. I found this a lot, like these are inconsistent with each other. It's somewhere in one, it's not in the other one. Audit for quality and compliance. No checkbox should be tolerated. And communicate to management, employees, and contractors. Feedback and get continuous improvement on that. Don't keep training employees only. Management needs more training than employees because they are the decision makers. Summary and conclusion. We all know that all incidents are preventable. Process safety near misses are precursors of major incidents. We saw that. A quality incident investigation should reveal the weaknesses in the management system and process safety culture. It should not be closed at a high level or a immediate causes level. Helping avoid the misfortune completely or significantly reduce the consequences. Process safety competency and good process safety culture are must for writing good management program. And all these things and learning from process safety near miss is a proactive approach, as I said, and whereas learning from incident is a reactive approach for recurrence of incidents. However, learning from both can prevent the incidents. Once again, if you think safety is expensive, try an accident. Question, I think I completed in time.
Thank you for a very valuable information and presentation. Mr. Session Chairman, Dr. Naim Al-Faqir, you are with us?
Yes, sir. Thank you for your presentation, Mr. Ravindra. We have a couple of questions. Please, if you have any questions.
Can you raise your voice,
you have
please,
any
Dr. Naim?
You have any questions?
Thank you for your valuable presentation, and I have a little bit question. The first, a couple of questions. The first one regarding the difference between risk and hazard. This is the first question. The other question, really, in case we have operating a process or a unit or whatever at an operating variable that is beyond or higher than the upper limit, the upper value. In such case, can I accept the risk of operating it at a higher value than the top or the highest value acceptable for operation or not? Really, I am referring here to the risk matrix. We have the yellow area, and if you can elaborate on the yellow area, how to define the values that states in the yellow area, which is acceptable risk, but with some measures. Thank you.
Dr. Naim, the questions for Mr. Rajendar?
Rajendar. And also, you can ask Mr. German if you'd like. Is he available, Mr. German?
I did not hear, actually, the voice was too low.
Dr. Naim, if you can raise your voice and repeat the questions, please.
The earlier presenter, if possible. Mr. German first, because I have a question to him also. Mr. German, do you hear me?
No,
Mr. German.
The voice is not clear.
Voice
Dr.
not
Naim.
clear. Voice not clear.
If you can use the mic on the Zoom platform.
I don't know whether it's possible or not here, but seems there is no two-way communication. The other presenter also, Mr. What's his name? Ratenda. Mr. Ratenda, do you hear me? Also not hearing me. Okay.
I cannot hear anything. If you
Okay.
can hear it, you can repeat it, please, for me.
Thank you. Thank you. Thank you all. Thank you both.
Mr. Session Chairman, Dr. Naeem.
Go ahead.
If you can use the computer PC for your question.
Can you type the question, please?
First of all, do you hear me, Mr. Rajendra? Do you hear us? No?
Okay, just one moment, Doctor.
ما في قدرش اسمعنا.
Dr. Naeem, we can move to the next presentation and take the couple of questions after the second presentations for Dr. Rajendra to save the time.
Okay.
Okay. It's my pleasure also to move to the next presentations. It's titled Protection Layer Integrity Measurement and Illusion with Dr. Rajendra Dahaya from United States of America. And it's my pleasure to introduce you again. You are professional process safety engineer, senior technical service manager in loss control global services, which one of the member company from American International Group. Also, Mr. Brian Dahaya, Mechanical Engineering, University of Texas, USA. Please, the floor is yours, and then we can take all of the questions for the free presentation.
Okay, can you see my screen?
No, still not yet.
Okay. Can you see it now?
Yes, now.
Okay, perfect. Yeah. Okay, thank you once again, and let me continue with my next presentation. This presentation is focused on the integrity and availability of critical safety systems during the operations phase of the facility. Now, please note that the data collected and analysis is based on my estimate from personal experience visiting, multiple sites here in North America, interacting with oil and chemical site personnel. The behaviors and surprises captures are shared and discussed here in this presentation. If you look at this slide, it is the regulatory requirement for any industry, especially the high hazard industries, to demonstrate that the facility's hazards are identified and risk managed to acceptable level. Several types of hazard studies are done, such as PHAs, LOPAs, and all those things. So, however, a PHA only does not guarantee the safe operation. The outcome of the PHA must be incorporated in the management program effectively. As a result of the hazard studies, this is my favorite slide actually, layer of protection including preventive and mitigative measures are identified, designed and installed, and to prevent or mitigate an incident. Accordingly, after that, the management programs are developed and implemented to operate and maintain a facility, including these layers of protection, what is shown in the middle picture. These three steps, PHA, protection layers, and management programs are minimum requirement for operating high hazard facilities. These processes, if implemented correctly and effectively, will maintain the integrity and availability of safeguards. However, this is not true. Let's see over here. In this slide, I would like to share my favorite graphics to explain how well designed and installed safeguards deteriorate with time and leading to an incident. There are three scenarios here. The first one is the design stage. Risk management demonstrates how risks are identified, potential hazards are managed through adequate safeguards to an acceptable level. This is what I can prove that it's green now. This is normally the case when the site is built and handed over to operations. Let's see what happens after 1, 2, 3, 5, 10 or 50 years. This is what happened. A well-designed and protected facility does not typically stay the same after the design stage. Over time, safety systems can become disabled, degraded, bypassed, not maintained. In this scenario, knowingly or unknowingly, the facility is operating at a higher, potentially unacceptable risk with a larger gap. And management may be unaware this is happening in this figure to reach the point where 75%, like 3 out of 4 safeguards are not maintained. Many warning signs must have been neglected. In my previous presentation, I talked about those warning signs, process safety near misses. There are several proactive actions that can help minimize the potential for this type of scenario, such as investigating process safety near miss incidents, auditing, training, management reviews, key performance indicators called KPIs, emergency operating drills, and many more. Now let's look at the incident scenario. The third one, you have seen this probably many times. Management failure to maintain the integrity of safety systems is one of the primary root causes of major incidents, as we discussed. This incident scenario displays where all preventive and mitigative safeguards failed and an incident happened. The holes in the management in the safeguard represent a failure mode and indicate weaknesses in the management programs and or human performance. Thus, through robust engineering and maintenance practices, the size of the holes can be minimized and sometimes certain failure modes can be eliminated through engineering. This is my data collected in 2 slides. Typically, I ask the facility manager or discipline manager in a conference room these questions. The practice that world-class companies put into place beyond what is minimally required are then classified as best industry practices and shared with peers. I repeat here, data is based on my personal experience. So the first question comes over here is, do you know and understand the facility's hazards? And if you see in the table, you will find here almost everybody, this is a big yes by all site managers with full confidence. Yes, we do, and that's a requirement. The second question is, are those hazards identified and risk managed adequately? The answer is a big yes again by PSM covered facilities and more than 90% others. In most cases, PHA is the answer. However, poor quality PHAs are not uncommon, in which either the risks are not assessed or managed adequately. And the next is, are there management systems in place to maintain the safeguards? The confidence starts to diminish as the question moves towards documentation. The common answer is the PM program. However, there are gaps. If you look at the next remaining question over here, the next is there documented evidence to demonstrate that all safeguards are maintained and available, fully functional, and the current level of your facility risk is tolerable? More than 60% of the time, documentary proof could not be made available due to inadequate and inconsistent management programs. The next one is, the second last, does the management system in place adhere to the RAGA gap as a minimum requirement? Mid and small size PSM code facilities think they adhere, but in reality, no, they do not. Most programs of the large sites adhere, but not all here. And the final question is documented evidence externally verified and benchmarked with peers? Most PSM covered sites either employ a third party or a dedicated corporate team for audits. Very few companies benchmark against these peers. So let's see, what are the illusions associated with these ones? Because these questions are answered in the conference room. They're easy to answer, saying yes, yes, yes. But let's see what really happened. What's the illusion? All the yes answers were reviewed further and verified in more details by reviewing the management programs, records, visiting the control room, interviewing personnel, and physical check in the field. Most common findings are discussed in these 2 slides over here. Many of the findings offer surprise to the management also, and it happens even yesterday. The illusion first is management assumes that all safety systems are maintained. You see the list over here. Yet in the majority of the cases where formal maintenance programs are implemented, in more than 50% of the cases, there was no list of safeguards, testing methods, and frequency not defined, and no formal training for people how to do the inspection and testing of the system, of critical systems. Test records were either incomplete or not documented at all. Many small to medium-sized companies are still struggling for developing meaningful KPIs. Audit findings are normally very minor, but there were substantial gaps when you get into deep dive. The illusion number 2 is management assumes that relevant staff are trained in process safety management. This comes to the process knowledge management as per OSHA PSM or CCPS, the risk-based process safety. However, in more than 50% of the cases, only 45 to 60 minutes computer-based training is provided to cover 14 elements, which is almost nothing. 1 hour is not adequate for that. For namesake, a process safety training and competency program is implemented, however, not effective due to the inadequacy of the training. Now, difference between training and competency is not clearly identified. In few cases, need-based training is provided, otherwise, same CBT, the computer-based training is repeated as refresher training. The third one is, this goes to the operations, the illusion 3. The management assumes that all safeguards are available and operable. They are maintained by maintenance, that's what they think. So management assumes that there is a formal safety bypass program implemented. However, in more than 70% cases, I'm loud and clear here, a bypass permit is used just to get management approval, a signature to bypass a safeguard. The consequences of the bypass and interim measures are either not on the permit, the bypass permit, or poorly articulated. Interestingly, due to lack of process safety competency and poor process safety culture, management signs these permits without ensuring that if the process meets the intent. In this case, bypass simply means safeguard is disabled.
Dr. Rajender, 5 minutes remaining.
Okay. Board operators seldom know when to push the ESD switch and what happens after. You can see multiple ESD switches sitting in the control room behind their wall or on the sides. However, in most cases, either it is not documented or operator could not find it. Again, audit findings are normal, but very minor, but there are significant gaps once you get into deep dive. So what is next? Again, there is a very detailed paper on this process, very explanation and all those causes and consequences and best practices are mentioned in this paper. To take away, process safety team is normally accountable for educating the site personnel about the hazards associated with the plant and ensuring that the safety systems are maintained and facility is operated at acceptable risk. Differentiating between training and competency is a must. A training matrix identifies the level of training and competency for everyone. So awareness, training, and competency are 3 different things. Then continue need-based refresher training and certification for continuous improvement. Communicate the outcome of hazard studies to management and affected employees. Keep PHA report a live document and educate employees how and when to use it. Make it available to them, not hiding somewhere in the shelf or keeping in a hard drive. Make current process safety information available to all relevant employees. Now, to the maintenance, a list of all safeguards is must. Only then they can be included in the inspection, testing, and preventive maintenance program. PHA LOPA reports are the best source to create a list of the safety critical systems. A well-written and implemented safety bypass program, including the consequences of bypass and interim measures, and approval escalation process based on the criticality. For example, bypassing an alarm versus a safety interlock. It should be different criticality. And the timing on that, duration of the bypass, like you are bypassing a safety instrumented system, SIS, or it should be, some companies have more than 24 hours, you need an MOC for that. A simple bypass permit is included in the paper and following slide also. Communicating safety bypass is mandatory item during shift handover process. ESD system criteria are clearly documented, when to push it, what happens, and afterwards. And meaningful KPIs are pretty critical. They are the proactive approaches to learn from them. And process safety competency and culture are given high priority on these ones. This is the example of a safety bypass permit I have seen, and I created one over this which includes all the details which are really important for this. And safety system or SIS testing procedure. This is a procedure as well as a documentation for testing a procedure. Many companies, they say we do test EHD system, we do test all the critical safety system, but we don't document it. This is the document we need to have a particular procedure by different people and document those things. Summary, I will jump on directly to the summary here. Maintaining protection layer integrity requires three things. One, a robust management system. Number two, competent management and workforce. I'm not saying just the employees, I'm adding management and workforce, both. A strong process safety culture. The first step, documenting of the safeguards, then only an inspection, testing and maintenance program can be developed. And employees trained, because now supervisors, engineers and senior management make most of the risk management decisions. They need a more comprehensive process safety training to implement the management programs effectively and efficiently. I'm sure we all have read the quote, what is not measured cannot be improved. Meaningful KPIs and quality audits are integral part of the overall operating management systems. Full details in the paper. I cut short over here, and again, thank you very much. If you have any questions, please speak loudly.
Thank you, Mr. Rajendra. Mr. Session Chairman, Dr. Naeem.
Thank you very much, Mr. Rajendra.
If you can manage the questions, please.
Mr. Rajan, thank you very much for your valuable presentation. Please, do you have any questions for the audience, please?
Thank you all for your valuable presentations, and I would address my question to the first presenter regarding...
Dr. Naeem, can you raise your voice, please? It's not clear.
Not clear?
Now it's okay.
You can hear me now? You can hear me?
Yeah, if you can raise your voice again, please.
Then I have to shout. Hello? You hear me clearly?
Yes, yes.
Good. First of all, I thank all the instructors or all the presenters for their valuable presentations, and I would address my first question to the first presenter. My question regarding the risk matrix that he displayed during his presentation. Really, he defined areas in the risk matrix regarding the high risk and the unacceptable area for risk values, and the medium risk that could be acceptable with certain measures, and the third, which is the green, which is no harm or no hazard there. It is acceptable really. So I would like to ask the presenter if he has any criteria to define the risk value that could be considered high risk and unacceptable, medium risk and acceptable with some measures, and low risk or no risk, green area. This is my first question to the first presenter.
This is the question for Mr. German.
For Mr. German, yes.
Hear the questions, Dr. German?
Yes, I did.
Yes.
Okay. In general terms, when we have a risk matrix, the red area means there is something that needs to be fixed and action must be taken. In the yellow area, depending on company policies, sometimes is accepted, sometimes is not. The green means that no further action is required. But because of the matrix depend on the company, each company have their own system. My recommendation will be, if you are on the left-hand side of the diagonal, is pretty much acceptable. If you are in the yellow, but on the right-hand side of the diagonal, maybe for those cases, you can do a LOPA to make sure that you have enough safeguards. But again, I've been doing HACCP for different companies, and different companies have a different rules for the matrix. There is no specific standard that says A, B, or C.
Okay. Thank you.
You're welcome.
My other question to the second presenter, if possible, really it's about the operating variables. For example, if we have a plant and we are running the plant at one of the main operating variables is above the maximum value allowable. In such case, have we to shut down the unit if we cannot mitigate it, or there is a possibility to accept the hazard of operating the plant beyond the highest acceptable level? Also, if he can give me a clear difference between hazard and risk, please. Thank you.
Did you hear the questions, Mr. Rajendar, Dr. Rajendar? Please unmute.
No, I was, can you repeat, Mr. Yaqub?
Yes, there's questions, there's plans. They reach the maximum recommended running hours or maximum scheduled time for shutdown. It's possible to continue running this plant without shutdown with the risk that's case. And another question is about the difference between risk and hazard. That's what I hear from Mr. Chairman, Session Chairman.
Yeah, okay. So some facilities, they can run the facility beyond their shutdown time. If it is every 5 years or every 3 years, they can run it a little bit longer, but they need to do a fitness assessment that some of the critical equipment and systems, the reactors and other vessels and safety systems are not getting overdue. If they are even getting overdue, a fitness assessment is done and a process called deferral, inspection deferral or maintenance deferral needs to be approved properly by the management and justified that we can run for another 6 months or another 3 months or another 1 year based on the history of the equipment. So that can be extended and companies do extend turnaround because of several reasons. That is the first answer. That is possible. People do that. Companies do that. The second is between risk and PHA. So PHA is used very commonly by industries, and PHA doesn't answer for everything. So PHA is process hazard analysis, and there are different techniques of doing PHAs. PHA is not HAZOP. HAZOP is one of the techniques of doing PHAs. So PHA can be HAZOPs, PHA can be what-if checklist, PHA can be even hazard identification process. It also process hazard analysis. So risk is a combination of the consequence and likelihood of that particular hazards. Like I will give an example, quick example. A plane crash the consequence is very high, but the likelihood or probability is very low. And the risk can be high or risk can be low depending on how the likelihood is. So in most cases, in big severe consequence accidents, we try to reduce the likelihood of the incident. But let's say likelihood of a plane crash is very, very low, but if it happens, the consequences are extremely severe. So consequences are not reduced. So risk is a combination of this likelihood and probability, and that risk assessment is done under PHA. So under PHA we do risk assessment that is qualitative. Under QRA or LOPA, we do semi-quantitative or quantitative risk assessment. So risk is a combination different, and these are the risk assessment techniques. So definitely hazards, risk, these are used interchangeably. PHA, HAZOPs are used interchangeably. But you need to understand that what is the difference between those.
Thank you. Mr. Chairman?
Do you have any questions? Okay. Our next presenter, please, can you? Let's present our next presenter, Mr. Shihab Muhammad Saleh Al-Sobani.
Mr. Chairman, the voice is not clear.
More than this? Are you hearing me now? Do you hear me?
Can you raise your voice a little bit?
Do you hear me now?
Yes.
All right. Our next presenter, Mr. Shihab Muhammad Salih Subani. He is an independent consultant, and his interest in organizational and occupational safety and health. Okay? Please, Mr. Subani, Mr. Muhammad, the floor is yours. Okay?
Mr. Shihab, Mr. Shihab, can you...
Mr. Muhammad Shihab Muhammad. Do you hear me, Mr. Shihab?
Mr. Shihab, the floor is yours.
Mr. Shihab, the floor is yours.
Mr. Ibrahim, can you give the permission for sharing the presentation for Mr. Shihab?
Mr. Shihab, Muhammad Shihab. Muhammad Shihab, Subani, in Yemen.
Mr. Shihab, now not panelist as attendees.
Shihab.
Check the attendees, Mr. Ibrahim. Mr. Shihab with us as attendees. Can you switch the permission or give the access to him?
I think. Hi, Mr. Shihab.
Hello.
Shihab Muhammad. All right, Mr. Shihab. Do you hear me, Mr. Shihab? Mr. Shihab Muhammad, do you hear me? Mr. Shihab.
Mr. Shihab.
Do you hear me, Mr. Shihab?
Hello, can you hear me? Hello?
Yes, we hear you.
Please give me the permission to
Mr. Ibrahim, still Mr. Shihab as attendees, not as panelist. Can you switch the permission?
Switch the next presenter. All right. All right. Our next presenter, Mr. Salim Al-Sanusi. Mr. Salim Al-Sanusi, do you hear me? Salim Al-Sanusi.
Please, if you can give me the permission.
Salim Al-Sanusi.
Download the presentation.
Okay, just one moment, please. Mr. Ibrahim,
Salim
Mr.
Al-Sanusi.
Shihab do not have any access or permission to share his presentation.
سالم السنوسي. Mr. Shihab, do you hear me, Mr. Shihab? Shihab Muhammad, do you hear me? Mr. Shihab.
I can hear you, but I can't open the cam or the presentation. Please give me the permission.
أعطيه permission يعمل presentation.
Mr. Chairman, the permission is not allowed till now to Mr. Shihab to be panelist to share his presentation.
No, I don't have any ability to.
Mr. Shihab, can you share your presentation, Mr. Shihab?
Should I go out of the program and
laptop, please?
You can
share your presentation, Mr. Shihab.
Mr. Chairman, if you can switch, move to the next presentation, and
Mr. Salim
Shihab will be try to use the link again.
Our next presenter, Mr. Iyad Rawashde. Is he with us? Mr. Iyad, I think you are there. Mr. Iyad Rashide, I'm sorry. Iyad Rashide. Mr. Iyad, do you hear me? Iyad Rashide. Mr. Iyad Rashide.
Yes.
Do you hear me?
Yeah, I hear.
Okay. Well, let me present Mr. Iyad al-Rashaidi. His affiliation from Mؤتمر University, his interest in renewable energy, and I would like to give you the floor. Please, you have 15 minutes for your presentations. Go ahead.
بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على أشرف الخلق والمرسلين سيدنا وحبيبنا المصطفى عليه أفضل الصلاة والتسليم. أما بعد. My research paper about solar panel technology using nanotechnology, and I will share my screen now, and I will explain about my presentation. Solar panel technology using nanotechnology. The contents about my presentation will be...
Riyad, can you maximize your presentation, please?
Yes.
Just maximize the PowerPoint presentation.
Okay.
Thank you.
Okay. So my presentation will contain introduction and main problem and solve the problem. The solve will be about nanotechnology. I will talk about nanotechnology for solve our problem. My problem in this presentation is just on the solar panel. Solar energy has been exploited science and time over time. Invented by different technology take advantage of this energy. One of the most important technologies that have been developed in solar energy is the manufacture of solar panels. The development of solar panels is through several stages to increase efficiency and exploit most of the solar radiation falling on them. The components of the solar panel, most solar panels are made up of a series of silicon crystalline cells sandwiched between a front glass plate and a rear polymer plastic sheet supported within an aluminum frame. Solar photovoltaic cells or PV cells convert sunlight directly into DC electrical energy. There are 6 main types of solar panels which use different type and size solar cells. The front glass sheet protects the PV cells from weather-like temperature, humidity, and wind. The aluminum frame protects the edge of the laminate section housing the cells. The EVA is a specially designed polymer, highly transparent plastic layer. How does solar PV work? The PV modules gather solar energy in the form of sunlight, convert into direct current DC electricity. An inverter can convert this DC power into an alternating current. The base of the PV cells is a very thin wafer, typically 0.1 millimeter thickness, and is made from either positive P-type silicon or negative N-type silicon. Factor affects convergence efficiency in the solar system. Temperature solar panel efficiency varies with temperature. According to some research, temperature affects typically value of solar PV system. Efficiency loss is 0.5% Celsius above 25 Celsius, and this is shown in the data sheet for the solar cells. The soiling material that accumulate on the surface of PV panels can block light from reaching the solar cells. Like about the snow, we can solve the problem when we design the project. We can increase the tilt angle for the solar panel, and then we will solve the snow problem. In my research, I will focus about the dust on the shading. Shading is the abstraction of hydration and do it self-shading trees, building, fern, and other objects. Reflection by minimizing the amount of light reflected away from the cells to surface. This picture from our effect on the productivity on the solar panel. System of production facility for 2020 and 2021, where cells were cleaned in 2020 and not cleaned in 2021. Let's focus on the month of full July and August, where this 2 month dust is as high as in our area, and every region of the world has the most famous probability that the dust is higher than other months. So if we see about July, the productivity, it's 867, and in August 841. But if we move to 2021, when not clean, the July is 788 and August 700. Is nanotechnology. Nanotechnology is the control of the matter at the nano scale, 1 billion of the meter, where in this scale, chemical, physical, and biological properties can change it. So we can manipulate matter at this length scale to get new properties. Now about the application of nanotechnology on solar panel. Tempered or glass is a type of safe glass processed controlled by the thermal or chemical temperament to increase its strength. It is used in a variety of applications such as solar panel. Tempered glass is about 4 times stronger than regular glass. And this is very important about our project. The inner stress tempered glass increased strength. Analyzed glass is still and break into
سيد إياد.
Glass is considered safe glass. Yes.
Mr. Iyad, we cannot hear your voice. Mr. Chairman.
Yes, Mr. Yaqub.
Maybe we have bad connection.
Yeah, we have bad connection, Mr. Iyad. Let's move to the next presenter or what? What do you think?
Mr. Iyad, you are with us?
Mr. Iyad, do you hear us? Do you hear us, Mr. Iyad? Iyad?
If you can share your presentation again, please, Mr. Iyad.
Yes. Mr. Iyad.
If you can maximize, Mr. Iyad, your presentation.
Yes, yes.
Okay, you can continue.
It's okay?
Yes.
Okay. Additional features for solar glass nano coating. Nano coating is a very thin, optically transparent plastic polymer film. So prevent fluorine. The coating can be added to solar glass by plating one layer of nano coating film on it. Coating will make the glass hydrophobic, dust repellent, self-cleaning properties, and produce more electricity than equivalent non-coated panel. New type of glass with a thin layer of about 10 to 25. Can you hear me, Mr. Yaqub?
Yes, but we have a little bit of bad connections, but it's, you can continue.
Okay. So a new of about 10 to 25 nanometer of tethered or silica is coated on the glass surface. Catalytic and hydrophilic.
Mr. Iyad, the voice is not clear. Your internet connection maybe is poor. If you can go to the conclusion and recommendation from your side, maybe better, because we don't hear you clearly. Yes, Mr. Iyad. Mr. Chairman, Dr. Naeem.
Let's move to the next presenter, okay?
Maybe we have a very bad connection with Mr. Iyad. We cannot wait.
Okay, let's move to the next presenter. Is it okay or not? Let's move to the next presenter, Mr. Muhammad Abu Rish, okay? Mr. Muhammad Abu Rish.
Please unmute, Mr. Muhammad. Unmute, please. The voice is not clear, Mr. Muhammad. Please unmute. Still not clear. There's no voice. Mr. Muhammad, you can remove your mic. Maybe there's some problem with your.
Hello, do you hear me now?
Yes.
Yeah, very clear.
Okay.
But let me try with my mic. Let me try.
Okay.
Do you hear me now?
Yes.
Yes.
Yes. Mr.
Is it okay?
Mr. Muhammad Abarish, do you hear me?
Yes, yes.
All right.
Speaking, I'm hearing you. I'm hearing you well.
Well,
Do you hear me?
Yes.
Everybody's hearing me?
yes, we do.
Okay.
Okay. Well,
Okay.
you have 15 minutes for your presentations, please. Go ahead.
Sure, sure.
Okay.
Can I get started? I can go start. All right. Bismillah ar-Rahman ar-Rahim. Are you shared or what?
Yes, but please maximize your presentation.
Is it okay now?
Yes, thank you.
Is it okay?
Yes, you can
Okay.
start.
Thank you for accepting me to talk through this this conference, Jordan International Chemical Engineering Conference. My name is Mohammed Abarish. I'm water and wastewater treatment specialist and freelancer for that. Today, I'd like to talk about heavy metals removal from water using low-cost adsorbent. This is a very simple topic to talk about. However, it's very important to start. I get started now. Okay, this talk. The first topic that I'll talk about, the outlines of my talk will be about first introduction, and I'll go to talk about the health effect due to heavy metals. Then I will talk about heavy metals treatment technologies. Then I will compare each others. Then I'll talk about the low-cost adsorbent cheat to sand, then calcined phosphate, and then I focus about sewage, sludge-based activated carbon. Then we'll go to the conclusion. Let's start with our introduction. First of all, let's talk about what the definition of heavy metals. You can say heavy metals are the elements of transmission elements in the periodic table, such as iron, chromium, zinc, which are present in water. The presence of heavy metals cause toxicity and environmental effect, as well as health effect in water and against human health. Where can we find it? The pollution sources are from industries, as well as such as due to industrial activities such as electroplating, covering coating, anodization, cleaning, milling, and many, and also petroleum refining, and other industrial pollutions. So generally, mostly it's due to industrial pollutions. Let's go to show you the response, the reasons for the presence of heavy metals reported by WHO, World Health Organization. First of all, let's talk about let's take an example of arsenic. It can be found in groundwater where there are sulfide minerals. Another example is uranium, for example, due to the nuclear plant, nuclear activities. And next topic is the health effect. Also, there is a maximum contamination level. let's focus on the MCL maximum contamination level. If you focus on it, it's not reported in milligram per liters. However, it is reported in microgram per liters, which shows its effect either in small concentrations, traces. For example, if you see how chromium is toxicant at 50 microgram per liters, whereas cadmium is causing kidney damage and renal disorder at 10 microgram per liter. As you see, these tables are reported by World Health Organization. Now, let's talk about treatment technologies. The most important technology for the removal of heavy metals in water is the adsorption. However, let me list you the previous technologies: chemical precipitation, membrane technologies, ion exchangers, electrodialysis, coagulation, aeration, and adsorption, which we will focus on. Here, comparison between each technology, advantages and disadvantages. The simplest technology is chemical precipitation. However, its disadvantage is sludge generation. Now let's talk about chitosan. It's one of the adsorbents necessary for the removal of heavy metals from water. Chitosan is the polymer obtained from the acetylation of chitin, product of the cover of fishes. Also, it has its impact on, usually when we talk about the adsorption process, the performance of the adsorption is based on the, it's measured by milligram. Hello? Yeah. It's measured by milligram of removal per gram of the adsorbent itself. This is the performance parameter for the removal. All right? Okay, hello? Hello? Yes.
You can continue, Mr. Muhammad.
Yes, thank you very much. Okay, if you focus on the pH, the optimum pH for the removal of the heavy metals by adsorption, it's mostly from 4 to 8. Mostly acidic medium is the optimum condition for the removal of heavy metals. Calcined phosphate. The calcined phosphate, it has its impact for the removal of lead and zinc, as you see here. It's very important to do many tests to optimize your performance of removal efficiency. If you see here for the removal of lead, it's optimized at the pH less than 5. Excuse me.
Mr. Ibrahim, can you unmute your computer?
Yes, I wish I continue freely. However, at some level you cannot remove more. So it's very important to select the necessary concentration that you can remove the heavy metal efficiently. Now, this is the most important topic that I will focus on through this presentation: sewage sludge-based activated carbon. Many tests, and there are future prospects for the removal of heavy metals through sewage sludge activated carbon. Activated carbon. What is the activated carbon? It's prepared from organic rich material, waste or biomasses. So why we need for activated carbon? Because it's rich of organic materials which can be converted through through a lot of processes into activated carbon. So where can we get our activated carbon? Simply we can have it from primary sludge, secondary sludge, dewatered sludge after digestion, and I prefer to be digested sludge after being dewatered and dried. Let's talk about the process for the production of sewage sludge activated carbon. There are two, for the preparation, there are two processes, carbonization and then activation, using physical activation and chemical activation. The carbonization is using the high temperatures, 500 to 800, under inert air, so without oxygen. They are using carbon dioxide. The optimum carbonization is achieved at 850. The carbonization at 500 to 600 forms micropores, which we need for micropores. However, while at 700, we can find, at 700 centigrade, we can find micropores, which is very important to increase the surface area of the activated carbon. Now, we finalize the carbonization using carbon dioxide with inert air. Let's talk about the activation using physical activation and then chemical activation. The physical activation is utilized by carbon dioxide, steam, or air. So there is air here necessary for the formation of activated carbon at 700 to 1100, while 800 is the optimum process, 800 centigrade. Now the chemical activation is necessary to improve absorption of the chemical carbon against the heavy metals or other contaminants. So they are widely used potassium hydroxide, sodium hydroxide, zinc chlorides, phosphoric acid, sulfuric acid.
Mr. Ahmed, 5 minutes remaining.
Yes. I will finish within 3 minutes also. Sorry for that. Okay. By activation at potassium hydroxide, it achieved for the formation of activated carbon 1,800 meters square per gram. Imagine this high, it will create high performance. Now I have last two figures. Let me finalize it. It's very important to notice that at certain level you cannot remove more activated carbon, as you see here through through tests. It's optimized at pH equal 5, and here for the removal of zinc and lead. Okay. Here we remove the mercury at pH. The optimum pH is 6. The optimum pH for the removal of mercury is at 5. For the lead as at 4. For the chromium at 5. For the copper at 4. As we find the optimization. Let's conclude our presentation. Heavy metals contaminated water has a great negative impact on health. Most of resources are from industrial applications. Many techniques of heavy metal removal from water were studied, such as chemical precipitation, adsorption, ion exchanger, while adsorption is currently more widely tested and proposed for the purpose of the treatment. Commercial activated carbon is used for the treatment. However, its disadvantages are its expenses and transportation. Thus, there are many attempts and trials for carrying out studies of heavy metal removal by low-cost adsorbent. So why we have to go for low-cost adsorbent? Therefore, due to cost and operation cost and capex and opex, then the most preferable activated carbon, which is still under research, is sewage sludge activated carbon. attempts are carried out to investigate removal performance. Thank you for your attention, and may I have your questions?
Mr. Chairman?
Yes, Mr. Yaqub.
Thank you so much.
Thank you.
If you have any, we have only one question. Only one question, yes.
Mr. Chairman, Dr. Naeem? Can we go back to Mr. Shihab Suhbani? Because he is now online and ready.
No. Okay. One question for Mr. Muhammad can ask. Hello?
Yes, I'm hearing. Yes, tell me.
Mr. Muhammad, just you prepared activated carbon from activated sludge. Have you checked the prepared activated carbon if it contain any heavy metals because you prepared it from sludge, activated sludge? Usually, sometimes activated sludge could contain you heavy metals. Sometimes, heavy metals is not easy degradation. Have you checked the prepared activated carbon if contain heavy metals or no? Thank you.
Okay, thank you very much. You raised a good, excellent question. Yes, you are right. The heavy metals presence in activated sludge is expected. So, however, the application of activated carbon is to remove heavy metals, not for this case, not for drinking water, because not for drinking water, for treatment of for recycling or something like for recycling or irrigation or what, not irrigation, for recycling or wastewater effluent treatment of wastewater treatment. However, there should be an attempt from governments to apply for heavy metal removal before being disposed into sewer lines. Before being disposed, because therefore any industrial application should have their strict application of inside industrial wastewater treatment in order to have activated sludge free of heavy metals. By the way, let's talk about our status in Palestine, in Gaza. In Gaza, we have less industrial applications. So our activated carbon in Gaza is, heavy metals presence in activated sludge, in sludge itself, is rare in Gaza due to our situation of industrial,
thank you,
industrial application.
Thank
I wish I answered the clear question.
Yeah, thank you. Mr. Dr. Naeem, Mr. Chairman, you are with us?
Thank you.
We can move to the
now
next
we are
speaker.
going to introduce Shihab Muhammad Sofani.
Mr. Shihab
Sofani.
And his presentation is titled with Encoded Safety Instructions.
Yes, he's from
The floor
Yemen.
is yours, Mr. Muhammad. You are a safety consultant from Yemen. The floor is yours.
Assalamu alaikum wa rahmatullah. Good morning, everybody.
Please, Shihab, you have just 15 minutes. So, 15
Mr. Ibrahim,
minutes.
can you unmute your computer, please, so that we can start? And if we have any questions, all the speakers will be with us until the end of the sessions. Okay, please, Mr. Shahab.
You can hear me and you can see the presentation or not?
Yeah, very good.
The presentation. Okay, we will discuss this subject, encoded safety instructions. First of all, we will take this presentation in separate places and through definition, importance, applications, difficulties, and standards, and the study and the results of this study. First of all, we must say safety first. It's not just a slogan, it's a way to life, especially in the chemical field, which safety is considered is the arc of the chemical engineering activities. Therefore, and for the purpose of simplifying, unifying, and ensuring efficiency and of identifying hazards safety instructions, rules, requirements, standards, and guidance of dealing with chemicals. Many and different encoded instructions were issued from many organizations. But the question is, what are they? Are we aware of its meanings? How do we use it? Is it suitable? This is the subject we will discuss in this study. I will clarify here the usage of encoded safety instructions, and this is the definition of the encoded safety instructions. In general, this encoded safety instructions indicates descriptive information which helps describing wide aspects of info related to the chemical field. The most important of this encoded safety instructions that it's easy of using, transcend the language barrier and literacy, effectiveness and efficiency of information delivering, certified and globally recognized. This is the usage of this encoded safety instructions that clarify the regulations, standards, guidance, specifications, requirement, identification, rules, actions, uses, etc. We use these instructions to show or to clarify the requirements needed to help the workers dealing with this dangerous chemicals, to describe the processes or the procedures, to describe or clarify the properties of the product, to show the consumers what's the risk or hazards of this chemicals or substances, also to clarify the equipments needed to deal with these materials, and to maintain the environment and keep it safe. This is types of encoded safety instructions. We can describe it or use it as a text, like danger, or in Arabic khatar, letters like EHS, extreme hazardous substance, or PPE, personal protective equipment. We can use it as logos, like this types of logos, symbols, also the symbols, shapes, the circle, the rectangular, this also the shapes indicates a specialty of safety instructions. Also the colors indicates also some kind of information about the hazards. Also the sound, and I have a lot of tones that each one indicates of some kind of hazards, like tsunami siren, nuclear siren, earthquake siren. There's different types of encoded safety instructions as a sound. Also we have lights. Different lights indicates, each indicates to a certain conditions. Also tools, but the most difficult things is the codes. This is what I am discussing in this paper. We use the encoded safety instructions to show the requirements, the legal requirements, such as CCA, Chemical Control Acts, Occupational Safety and Health, Waste Control Act. Also, we use it for purchasing the chemicals, because we have legislations governs this, especially that the extremely hazardous substance materials. We have UN number, we have CAS numbers that describes the quantity and how to the quantity of each material allowed to be transport or acquired, or what's the packaging of each materials is suitable for it. Also, we use this code safety instructions for transportation or transferring this substance. Also, we
5 minutes remaining.
Yeah, okay. I will jump off to the requirements. Okay. Yes, please. Also for PPE, I will jump off. In this paper, I studied this different types of encoded safety instructions, and I will give you the final results of the research. Okay, encoded instructions development. This is a need to be solved. A careful study of the receiver specifications when designing encoded instructions, developing the encoded instructions to be usable by people with disabilities, like people with vision disabilities, who can't read, who can't hear, developing the need of developing effort to create a unified authority responsible of developing unified systems. We have different systems. This is the most the most important issue that we are discussing in this study. I'm building a unified system to help responding to accident. All of the instructions telling us the hazards or the risk of the substance. But what we can do about if the accident happened, this is not clarified. We must get advantage of current new communication and technologies. If you can use the QR to describe, to make a link to describe the safety instructions in each bottle of chemical. And general awareness is essential. There is a necessity of improving occupational health and safety fields, unification and adoption of unified system locally and regionally. Governments should enable, encourage, and develop its national experts and professionals in this field, developing of educational training, research, and awareness in institutions to help teaching and understanding these encoded instructions. Media also have a big responsibility to spreading the safety and general knowledge about chemicals, supporting translation of international guidance and standards. I know the time is limited for this paper, but we have a lot of problems in reading the encoded safety instructions. We have this, for example, most of the fire extinguisher in Yemen doesn't have the colored label or something like that. We have this also problem with these instructions in the glove, EN 388, that describes that this glove is resistant to cut, but the logo is a hammer. So sometimes we are confused in the safety instructions because it's not designed properly. This is what I got in first description. This is what I say. Can you hear me?
Yes,
yes, thank you very much, Mr. Shah, for this valuable presentation. We will excuse Mr. Salim because he already in the hall. We can go to the next speaker. So that maybe presentation with Mr. Salim about the compressive strength of the concrete maybe will be last presentation in this session. We will move to Mr. Malik Sahlab about the presentation titled with using reason Swiss cheese model to investigate 2005 British Petroleum Texas City refinery explosion accident in terms of occupational psychology and ergonomics. Mr. Shahab, he is director of the National Palestine Center of Occupational Safety and Health and Environmental Protection. Please, Mr. Malik, the floor is yours. Can your presentation and can maximize your presentation, please?
Yes. Okay. Good afternoon all.
Okay, you can continue, Mr.
Can I stop?
Can you unmute, Mr. Shahab? Can you mute, please? Mr. Ibrahim, if you can mute the screen of Mr. Shahab. Okay, thank you. Mr. Malik?
Okay, good afternoon all. And first of all, I would like to thank the organizers and sponsors for the 9th Hybrid Jordanian International Chemical Engineering Conference for allowing me to participate. And also I would like to thank the chair of this session, Dr. Naim Al-Faqir, and the co-chair, Mohandas Yaqub Bani Taha. My participation will be about using Reason's Swiss cheese model to investigate the 2005 British Petroleum Texas City Refinery explosion. The content for this presentation will be, I will give a summary about the explosion, the serious events that contributed to it, and I will review the immediate and root causes. Also, I will analyze this accident on the Swiss cheese model. Lastly, I will talk about how to avoid recurrence for such accidents. As we know that this explosion happened on Wednesday, 23rd of March 2005 at 20 past 1. The losses were 15 deaths and over 180 injuries, and the financial losses were over $3 billion USD. And this accident considered one of the worst blasts happened in the petroleum refineries in the modern age. From this aerial photograph, we can see that the explosion caused by the overfilling of the raffinate splitter tower and blowdown drum releasing hot hydrocarbons. The resulting vapor cloud ignited, destroying the ISOM unit. This is the raffinate tower, and this is the blowdown drum. And as we can see also the trailers, where most of the fatalities happened. Over 12 fatalities happened in these trailers. We can also see from these photos the isomerization unit, the damage that happened there. Also, the damage that happened in the supply control room, also for the trailers. And as I mentioned before, that over 12 fatalities happened in these trailers where the contractors were meeting there. Serious events that contributed to this explosion, or let's say it's the chronology of this accident, started from the 2 a.m. Where 6.5 feet of the liquid that should be pumped into the base of the tower. At the bottom of the tower, there was a gauge installed to measure how much fluid was there inside this isomerization or the splitter, and this sends this data to the control room. This gauge designed to measure a maximum of 10 feet of liquid, but over 10 feet, the operators would have no knowledge on how much of the liquid is there. As the tower overfilled higher than the specified level, suddenly the alarm activated and buzzed in the control room, and an additional redundant alarm failed to operate. You can see that there is a faulty equipment. At 30 past 3 a.m., the liquid feeding was stopped as the level gauge displayed that the fluid had filled the bottom of 10 feet of the tower, but the gauge was not providing accurate reading. It wasn't calibrated correctly, while the actual level was around 13 feet. At 5 a.m., the lead operator gave an update for the board operator about the operations in the control room, and unfortunately, he left his shift 60 minutes earlier. At 6 a.m. in the morning, a new board operator arrived that morning to start his 30th straight shift. He read the logbook briefly, but nothing mentioned about the liquid level in the splitting tower. 15 past 7 in the morning also, a day shift supervisor also arrived late and received no update on the status of the unit, how much liquid is there. 10 to 10 a.m., operators started circulating the fluid feed by pumping more liquid to the already overfilled tower. The tower flow out valve was left closed 10 minutes later. At 10 o'clock in the morning, workers ignited burners to begin heating up the pump liquid. During this, the workers weren't aware that the tower overfilled by 20 times than the normal level, while the gauge showed that the liquid level was below 10 feet and dropping. At 11 o'clock, the supervisor left the refinery responding to a family medical emergency. During his absence, unfortunately, no experienced supervisor was chosen to place him, and letting an inexperienced and unsupervised operator to work alone without any supervision. 12 o'clock, the liquid level in the splitting tower reached almost 100 feet high, but the faulty gauges again showed a height of 8 feet and slowly dropping. 20 to 1, a high pressure alarm was triggered. As a result, the dual burners in the heater switched off to lower the fluid temperature, but the valve which controls the pressure didn't open. A worker opened a manual chain valve to exhaust gases to the blow-down drum and then to vent it to the air. 1 o'clock, to reduce the pressure inside the overfilled tower, operators opened a valve to send the fluid from the base of the tower to a storage tank. This raised the temperature of the pumped fluid into the tower to up to 150 degrees Fahrenheit. At 1:05, the pumped liquid into the tower started boiling and expanding, causing the level and pressure inside the tower to increase more and more. At 1:10, the liquid started to overflow onto the piping at the top of the tower and then build up in the vertical piping, which exerted excessive pressure on the three emergency relief valves located 150 feet lower. 1:14, the three emergency relief valves opened, liquid starting to flooding to the blowdown drum. Then at the end of the isomerization unit, liquids flooded from the blowdown drum into a process sewer. Then the alarm installed on the blowdown drum didn't go off, unfortunately. Then the blowdown drum filled totally, resulting in a flare-up of liquids from the top stack to the ground, generating a large cloud of flammable vapors. At 1:20, the ignition of the vapor cloud happened, producing a sequence of explosions. It's said to be that the source of the ignition came from a diesel pickup truck that was stopping around 25 feet from the blowdown cylinder, and unfortunately it was open. From this photo, we can see that there were faulty equipment, closed, as we see, closed vents, closed valves, and some sensors were inoperative. Here we can see the inoperative valve, safety relief valve, and here the sensor was inoperative. Here as well, side glass dirty and unreadable. That shows the level of the liquid inside the splitting room. The immediate causes for this accident were operators' fatigue and errors and the absence of fatigue remedy policy, as we saw that one of the operators started his 30th shift, and then poor design of the control displays and meters, poor ergonomics, where two readings came on the same screen, and the operators feel confused about reading the data immediately. Faulty gauges and level meters, deviation from safe startup and procedures, and also ineffective and poor communication at shift handover, like the first operator didn't tell the second operator about the level of the liquid inside the splitting tower. Overfilling the splitting core also, and the high pressure built up, the vent valve, as we said before, was closed, failure of the emergency relief valves to open, absence of experienced personnel during the startup and shutdown of operations. Also, inexperienced operators was there, and he is not familiar with the startup and shutdown operations perfectly. Combustible liquids erupted on the ground from as a failure of the blowdown drum. The diesel truck that was parked very close to the blowdown drum. The root causes absence of programs for managing major hazards and risks, and as we know, this is this refinery considered a high-risk industry or falls under the regulations, the control of major accidents hazards. This is a UK-based regulation. Also, the poor safety culture and leadership. Maybe from the investigations, it showed that over like 6 to 7 leaders were changed within 2 years, and this is too much for such organizations. Cutting crucial budgets, and it's to be like 25% happened as a cutting cost, weakened the process safety performance, absence of an active reporting and learning culture from previous accidents. Also, incidents investigation were not carried out perfectly, and if so, an appropriate corrective action was not taken, lack of proper training programs for operators.
Malik, 5 minutes remaining.
Yeah, I'm almost there. Focusing more on personal safety and ignoring process safety, weak operational policies and procedures, poor and obsolete design of the ISOM unit and fault equipment, lack of automatic controls in the steering tower to monitor the level adequately, lack of supervision, lack of effective and proactive maintenance programs, lack of active vehicle traffic policy, lack of active communication through the unit startup and shut down, lack of effective site management, as we saw that the trailers were very close to the blowdown drum. By modeling on the Swiss cheese model, as we know the principle that accidents occur through the aggregation of several factors and failures, organizational, personal, and workplaces. Barriers here represent the slices represent barriers, and the holes represent the weaknesses. Okay, this is also for the Swiss cheese. Now I have modeled this on the Swiss cheese model, and as we know, this Swiss cheese model was a model for accident causation theory. We can notice here that the relief, for example, let's see the barriers, control, alarm, and shutdown system, this should be adequate, but the failures and weaknesses that operate outside the envelope, no fail-safe shutdown, no mass balance or attention to other data. For example, for the maintenance and inspection, fault high-level alarm not reported. For the communication, this is the layers of protection. Let's say for the communication, no effective handover between shifts, and the unit alarm didn't sound. This is the modeling of these accidents. In conclusion, and to avoid recurrence for such accidents, we should provide like a clear system of accountability at the chain of command, providing fatigue prevention programs, presence of supervisors at startup and shutdown operations, providing proper training for operators, providing ergonomically designed control rooms, maintain updated operations procedures with continuous follow-up, redesigning the refinery layout to separate trailers and people from hazardous process to safe place, implementing a positive safety culture and leadership, which is the most important point in such accidents and refineries, considering human factors when designing any process or plant. Lastly, implementing assessment programs for employees, ensuring that all alarm systems are working and updated at the plant, and workers are familiar with distinguishing each warning. Updating and redefining the isomerization unit and vent system. Lastly, compliance with process safety requirements. Thank you for listening, and if there is any question, I am ready.
Thank you, Mr. Malik, for this very valuable presentation. We have 2 minutes. You can take questions from attendees in the hall or from Zoom platform. If there's questions, please. If you don't have the questions, we will move to the next presentations by Mr. Abdulaziz Al-Zamli. The title of this presentation will be Study of the Impact of the Tube Configuration on Local Heat Transfer Coefficient in Bubble Column Reactor with Heat Exchanging Tubes. This is non-process safety topics, but Mr. Abdulaziz, Department of the Chemical Engineering, University of the Technology from Baghdad, Iraq. Mr. Abdulaziz, Dr. Abdulaziz.
السلام عليكم جميعا ورحمة الله وبركاته.
Please, if you can share your presentation, Dr. Abdulaziz.
I shared with you.
No, still not yet.
Okay.
This is your presentation?
Yep.
Can you go to the next slide?
Okay.
Okay, thank you.
السلام عليكم.
Mr. Dr. Abdulaziz.
العفو عبد الرزاق.
عبد الرزاق. آسف.
العفو. مشكلة. أبدي؟
Yes, please.
السلام عليكم جميعا. أنا الباحث عبد الرزاق ناظم من العراق بغداد، طالب دراسات عليا في الجامعة التكنولوجية قسم الهندسة الكيميائية. اليوم راح نتناول بالبرزنتيشن الخاص بنا دراسة study of impact of tube configuration, on local heat transfer coefficient in bubble column reactor with the heat exchange tube. Another author الدكتور عامر عبد العزيز والدكتور عباس جواد سلطان والدكتور ليث صبري. راح نتناول ان شاء الله الاوتلاين الخاص بالبرزنتيشن مالتنا، الانترودكشن والاكستي اوف تكنولوجي والبابل كولوم اند سلري بابل كولوم والفيرتيكال هيت اكسشينج تيوب والاوبجكت اوف ذا ريسيرش والاكسبيرمنتال سيت اب. بما يخص الانترودكشن، نتيجة الزيادة الحاصلة في كل من الجانب الاقتصادي وكذلك في الزيادة الحاصلة في الطبقة الوسطى من المجتمع وأيضا زيادة البنى التحتية، فهذا كله يتطلب توفير طاقة والتي أغلبها يعتمد على مصدر النفط الكرود أويل. ونتيجة هذه الزيادة على الطلب على النفط الخام الكرود أويل يؤدي إلى استهلاك وتقليل كمية ما مخزون من الكرود أويل، وهذا التزايد يتسبب لنا في زيادة الانبعاثات للبيئة وزيادة الانبعاثات للبيئة، ومن زيادة تقليل هذه الانبعاثات والحصول على بيئة ملائمة للعيش التجأ العالم وكذلك المحافظة على مصادر الطاقة ما متوفر من الكرود أويل. اتجه العالم لتوفير بدائل للتقنيات، ومن بين هذه التقنيات هي تقنية الاكستيال تكنولوجي. الاكستيال تكنولوجي هي تقنية تحويل الناتشورال غاز عند الكول عند البايوماس وتحويلها إلى وقود سائل من خلال عملية الفيشوتروبش. وظهرت هذه التقنية كبديل للتكرير التقليدي للنفط الخام، حيث أن هذه التقنية توفر استثمارات جديدة في الموارد الطبيعية والنظيفة. وتتضمن هذه التقنية مجموعة من الخطوات لتحول الكول أو بايوماس أو ناتشورال غاز وتحويلها إلى ساينثس غاز، والذي يتم تحويلها إلى هيدروكربونات ذات وزن جزيئي أعلى باستخدام تقنية الفيشوتروبش. طريقة الفيشوتروبش، وهذه الطريقة تم اختراعها لأول مرة من قبل العالمين فرانس فيشر أند هانس تروبش في ثلاثينات القرن الماضي خلال الحرب العالمية الثانية لتوفر كمية كبيرة من الفحم. وفي عملية الفيشوتروبش يحدث تفاعل كيميائي يتضمن تحويل غاز أحادي أكسيد الكربون والهيدروجين وجود العامل المساعد إلى هيدروكربونات سائلة. وهذه التفاعلات تتميز بأنها تكون هايلو اكسوثيرميك، وبالتالي فإن التحكم في درجة الحرارة داخل المفاعل ضروري للحفاظ على أداء المفاعل وكذلك على الكتاليست الموجود داخله من الضياع أو فقدان الأكتيفيتيز مالتها نتيجة ارتفاع درجة الحرارة. في عملية الفيشوتروبش تستخدم مجموعة من المفاعلات، والتي من ضمنها الستري بابل كولوم أو ستري بابل كولوم والفيكسد فلويدايزد بيد والمالتي تيوبولار فيكسد بيد والسيركوليتنج فلويدايزد بيد. احنا راح نتطرق الى البابل كولوم، واللي هو مفضل في من بين المفاعلات المستخدمه في الفيشوتروبش هو البابل كولوم او ستيري بابل كولوم، حيث ان هذا المفاعل يحتوي على مجموعه من الادفانتج والاستخدامات والطبقات، حيث انه يستخدم في الووست water treatment and methanol synthesis and fermentation oxidation وفيشوتروبش ساينثيسيس. هذا المفاعل مالتنا مو مفاعل عادي، حيث انه يحتوي على مو بابل كولوم عادي او ستيري بابل كولوم عادي، بل يحتوي على باندل اوف هيت اكسشينج تيوب، باندل لتقليل درجة الحرارة. اكيد يحتوي على مجموعه من الادفانتج اند ديس ادفانتج. بالنسبه للادفانتج مالته يكون جود ماس اند هيت ترانسفير ريتس، easy of construction and operation, absence of moved parts, low maintenance cost. and they have another disadvantage. Significant base bag mixing and defect scale up and design. ونتيجة لهذه الديسادفانتج مالت الديفكت اوف سكيل اب لابد نتيجة لعدم توفر الداتا الريال داتا بالفيل توفر ريال داتا في الفيل عن هذا المفاعل البابل كولوم، وخصوصا عندما يحتوي على الانترنال فارتأى العالم ان يضيفون الانترنال لتقليلها اللي هو vertical heat exchange tube الذي يحتوي على مجموعة من الادفانتج فمن ضمنها high heat transfer efficiency is higher, improve mass and heat transfer rates, control of exothermic reaction, minimize of pressure drop. According to the literature, نحن لاحظنا انه عدد قليل من الدراسات تناولت البابل كولوم with internal، ولكن لا توجد دراسة تتضمن دراسة تأثير الأشكال على اللوكال هيت ترانسفير كوفيشنت في بابل كولوم. فدراسة الأوبجكت or aim of the project of research هو impact of heat transfer and local heat transfer impact of heat exchange tube configuration on local heat transfer coefficient in bubble column. واحنا سوف نتناول شكلين من ضمنها triangular and squared tube pitch arrangement، حيث ان هذه الاشكال تم تصميمها وبواسطة البرنامج سولد وورك، وكذلك تم طباعتها بطابعة 3D برينتر. هذا السلايد راح نتناول السيت اب مالتنا، حيث يوضح السيت اب مالتنا. ان هذا السيت اب مالتنا الخاص بنا تم تصميمه وتنفيذه بالعراق، حيث انه يتكون من كولوم قطره 13 سنتيم وارتفاعه 183 سنتيم، وكذلك يحتوي على مجموعه من الانابيب الانترنال التي يكون عددها 30 انبوب، وقطر الانبوب الواحد 12 مليم و12 مليم بارتفاع 190 سنتيمتر. وكذلك يحتوي على البليم الذي يكون ارتفاعه 30 سنتيمتر، وهو يحتوي على الغاز ديستريبيوتر، وايضا يحتوي على 2 فلوميتر للسيطره على كميه الغاز الداخل، حيث نستخدم في الاوبريشن كونديشن مالتنا السيرفيس سوبرفيشال غاز فيلوسيتي من 50 to 40 سنتيمتر، وكما ذكرنا انه يغطي الانابيب الموجوده داخل المفاعل تغطي 25% من مساحه الكولوم، وهذه النسبه ليست نسبه احتباطيه بل نتيجه ميميك تو اندستريال كونديشن، نسبة إلى الظروف الصناعية، حيث أنهم يستخدمون 25%. هاي الصورة توضح السيت اب اللي مستخدم داخل المختبر الخاص بنا بالجامعة التكنولوجية. الآن نتناول التقنية اللي هي ترانسفير تكنيكال لقياس اللوكال ترانسفير كوفيشنت. لازم نستخدم مجموعه من المعدات التي تكون معدات تم استيرادها من ذات ناشئه عالميه، ومن ضمن هذه الاجهزه والمعدات هي الهيت ترانسفير بروب والثرمو كابل والدي سي باور سبلاي والامبليفاير والداتا انسترومنت، والتي سيتم توضيحها تبعا. اول شيء سوف نتناول هو الهيت ترانسفير بروب. هذا الهيت ترانسفير بروب تم تصنيعه بالعراق، حيث ويتميز هذا الترانسفير بروب باللاست يعتبر هو من التقنيه الحديثه لقياس الاندستريال اللوكال ثيرمال انرجي اند هيت ترانسفير كوفيشنت، حيث ويتم تصنيعه مثل ما ذكرنا بالعراق، حيث انه اتينا بقطعه من البراس وتم حفرها بواسطه اجهزه ووضع داخله هيتر ولصق ووضع قطعتين من التفلون كما موضح بارتفاع نصين 2.5 سنتيم ب 2.5 سنتيم لمنع تسرب الحراره. وتم لصق السنسر الخاص بنا الذي يتميز هذا السنسر بقياس اللوكال تي ترانسفير كوفيشنت وكذلك تي سيرفيس.
سيد عبد الرزاق 5 دقائق ضايل 5 minutes.
تمام. وكذلك يحتوي على مجموعة من المميزات. هذا السنسر الخاص بنا يكون هايلي سنسيتيفيتي وكذلك ثين سنس وفلكسبيليتي عالية خاصة. هذه الصورة توضح انه شلون موجود في البابل في الكولوم. هاي الثرموكابلات الخاصة بنا اللي هي تايب كي، حيث لقياس البالك تمبرتشر الداخل، حيث نستخدم انه السيستم مالتنا حيكون عبارة عن مي وهواء. الامبليفاير مثل ما السنسر مالتنا يتعامل مع اشاره دقيقه جدا، حيث يعطي اشاره بالمايكرو فولت، والداتا الخاصه بنا وتعرفون تتعامل مع الفولت، فيجب تحويل المايكرو فولت الى فولت، وذلك باستخدام الامبليفايرات. طبعا السنسر من امريكا والامبليفايرات كذلك من امريكا، حيث مثل ما قلنا انه السنسر يقيس شغلتين، واحد هيت فلكس وكذلك يقيس تي سيرفيس. تم استخدام 2 امبليفاير لتضخيم الاشاره وبعدها نقلها الى الداتا اكوزيشن انسترومنت. وهذه الداتا من منشأ الشركه الناشونال انسترومنت، مثل ما تعرفوها شلون شركه عالميه وذات، حيث هذه الداتا is the process the measurement of electric or physical phenomena such as voltage, current, temperature, pressure or sound. وكذلك التعامل contains single condition and analog to digital converter but need to contact the computer to function. كذلك يتم بعد جمع المعلومات، جمع الداتا مالتنا يتم وضعها في المعادله الاتيه اللي هو تي سيرفيس حصلناها من السنسر، والبالك عندنا مثل المكابلات، والاتش والكيو حصلناها كذلك من السنسر، ويتم وضعها بهذه المعادله والحصل على اللوكال ترانسفير كوفيشنت. هاي البروسيبيليتي اوف ميجرمنت استخدمناها، حيث كانت نسبة الفرق بينها للتأكد من دقة الأجهزة المستخدمة، حيث كانت نسبة 3% فقط. طبعا بين هذه القياسات بين يوم، مو نفس اليوم، بين يوم يعني وراء another time. هاي سامبل اوف كالكوليشن، واحنا في طور جمع الداتا التي ان شاء الله في القريب العاجل يتم نشرها والتزويد الفيلد بالريال داتا حتى يستفادون المصممين من عندها لتفيدهم بالسي في سيميليشن، وكذلك لتطوير السكيل اب حتى ما تكون اي مشكله في هذا، وكذلك في الموديل إذا يحتاجون معلومات عنها. هاي الريفرنس استخدمناها. هذا التيم الخاص بي قدم الشكر لهم اللي مساعدتهم تم التوصل إلى نتائج رائعة. وكذا شكرا جزيلا. أن أي تواصل أو أي سؤال عندكم أنا على هذا الإيميل والرقم. شكرا جزيلا للاستماع
شكرا جزيلا سيد عبد الرزاق على المحاضرة القيمة. الآن راح يصير السيشن شير الأستاذ الدكتور أحمد شواقفة. Mr. Chairman. الدكتور أحمد.
تفضل دكتور يعقوب، تفضل مهندس يعقوب. ضايل واحد ها. في سنوسي سالم سنوسي. سالم سنوسي are you there؟ ها؟ اوكي. اي موجود مهندس يعقوب. وجاهي المحاضرة تبعتهم مش اونلاين.
عشان هيك حضرتك بتدير الجلسة.
اوكي ماشي. الله يعطيك العافية وبارك الله فيك. ثانك يو فيري ماتش.
كل الاحترام.
الله يعطيك العافية.
السلام عليكم.
السلام ورحمة الله وبركاته. there's a glitch in the Dr. Salim presentation. So we need to fix. So I need to switch the two lectures. The one for Professor Mohammed Ahwiti. Professor Mohammed Ahwiti is أستاذ في الهندسة البيئة جامعة الحسين طلال، عميد كلية الهندسة في جامعة الحسين طلال، وحاليا مدير البحث وتطوير الأعمال في شركة مناجم الفوسات. Professor Dr. Mohammed Ahwiti, he's an environmental engineering professor, former dean faculty of engineering at Al Hussein bin Talal University, currently director of the research and business development at the phosphate company, right? You have, you know how much you have minutes.
بسم الله الرحمن الرحيم. Good afternoon, ladies and gentlemen. My presentation in English. If you want to talk in English, it's okay. If you want to talk in Arabic, I'm going to talk in Arabic. What do you think? Arabic is better? Okay. Okay. Online? Okay. My presentation entitled Innovative Technologies for Recycling Phosphogypsum Produced in the Worldwide. So talking properly. So the question that maybe was now, why phosphogypsum? Is phosphogypsum is a waste or a resource? To answer for these questions, I'm gonna explain the following outline. As you see here, I'm gonna speak an overview about phosphogypsum, the phosphogypsum produced in the worldwide, the beneficial cycling in the world, management life cycle, and major ways phosphogypsum recycling, future action, and utilization. What is phosphogypsum? Phosphogypsum is byproduct produced when the phosphate rock react with the sulfuric acid to produce phosphoric acid. For each 1 ton phosphoric acid manufactured, 5 tons phosphogypsum produced. The other topics concerning the phosphogypsum is the beneficial uses if phosphogypsum is stable, durable, coherence, or consistency. To answer for all of these parameters, let me let you know the following. The phosphate rock extend from the north to extreme south. Shady deposits is the largest of all. The phosphate produced from these occurrences are mainly exported and partially consumed in phosphate fertilizer. Both phosphate rock and their fertilizers have long been to contain varying amount of heavy metals and radioactive materials. These materials, during different processing steps, may be distributed or redistributed in the phosphoric acid, DAP, or phosphogypsum. As you might see here from these figures, we have huge quantities of phosphogypsum stockpiled at Ashiriya and Aqaba. The total productions of phosphogypsum in the JBMC, 1.2 million tons produced in the stockpiled from the IGC, 1.9 million tons per year produced at Industrial Aqaba Complex, and 2.7 at JIFCO. The total quantities of phosphogypsum productions of about 6 million tons per year. And now we're talking about more than 100 million tons stockpiled in the Shiriya area and Aqaba as well. What we are looking for, and we have to point out to highlights, these quantities should be converted to commercial utilizations and to reach 0 million tons. How to manage these things? Different action plan, now GBMC planning to carry out. One of these conductions of the agreement with the National Chlorine Industries. We signed agreement with this company to produce 0.1 million tons per year. The final product is the calcium chloride. As you might see here from this figure, the phosphogypsum productions in the worldwide fluctuated up and down, and the high quantities during the 2016, we got reached 261 million tons per year. But in 2020, the quantities of phosphogypsum comes down, we got reach 150 million tons. The total phosphogypsum stockpiled in the worldwide around 6 billion. The stacks identified in the world in some 25 countries, the growing up 25 million tons yearly. The global phosphogypsum producing probably double in 2040. So you have to thinking all in the world how to demand or beneficially uses and make regulations or laws concerning these materials. The beneficial recycling found in the R&D in the worldwide, there are different utilizations for phosphogypsum. For example, phosphogypsum can be used for agriculture as amendment for the soil, conditioners, and reclamations. What else? Also for the road constructions, for building materials, construction materials, plastic, wallboard, or cements, in the landfill, ceramics, marine projects, and raw materials. If you go to the countries, and what about the applications of those countries concerning the phosphogypsum stockpile? Jordan, we get start to using the phosphogypsum in the large scale. We talking about the production calcium chloride. Also, some researchers conducted several researches concerning using the phosphogypsum in the cement, and a little bit work in the agriculture we will see later. USA using the main of the phosphogypsum using for the road constructions. In Spain, they are using phosphogypsum in the soil amendment. Belgium in the fine plaster. In Brazil, there is many uses of phosphogypsum in agricultures and in the buildings. Canada in the agriculture. China also agriculture, constructions, recycling, and ammonium sulfates. In Jordan, one of the good example of using phosphogypsum as you might see here, we using the phosphogypsum in the agriculture, and we get to planting the tomatoes and the pepper, and we get measured the heavy metals concentrations of these plants. The results reveal that all the heavy metals and radioactive materials are low content, which is good to continue applications, a large content of phosphogypsum in these topics. JBMC agreed MOU with the Center of the Agriculture to conduct intensive work of utilization of phosphogypsum in the agriculture. In Kazakhstan, large-scale remediation using phosphogypsum in the soil amendment. In India, there are many applications in terms of agriculture, soil amendment, in the cement. In Russia, also on the agricultural construction roads, and Tunisia, also on the remediation. What about the USA? As I told you, there is many applications of phosphogypsum in the USA focusing on the road constructions. This road was built in before 21 years. As you might see here, the road of phosphogypsum, the same as you see here. After 21 years, only joints or fracture appeared in the road. This means that phosphogypsum is a good example to using in road constructions. What about Brazil? Brazil also had application of BG phosphogypsum in the building. The whole building here consists of phosphogypsum. And they get measured the radioactive materials in terms of radon 222. And all the results also reveal that the radon concentration concerning the health public less than 1 millisievert per year. In Spain, also there is a lot of application of phosphogypsum in agriculture, and as you see here, the huge quantities used for the agriculture and the reclamation of the area. In India also, most of phosphogypsum were applied for the road constructions. In addition, in India there is a company adding some nutrients like magnesium, zinc, boron to the phosphogypsum, and they making the bag and sell for the client or consumers. That's it. Because the phosphogypsum already has the phosphor, has nitrogen and phosphor, and all are nutrients very important for the plant to uptaking those of nutrients. In Kazakhstan, also many application in the agriculture. The innovative wall structure using BG in China. The whole building, the smart building now in China using phosphogypsum. In Tunisia also, they made bricks from phosphogypsum, and they built a building with those bricks. This table shows the selective comparative management of BG life cycle. Countries that discharge of the phosphogypsum, if there is a stack working, if there is legacy, BG experiment use, commercial use, and the full site remediations. What we're talking about here, we need to focusing about the BG commercial use. As you see in the tables, for example, Brazil have stacking, and there is regulation how to management of these waste material. There is a lot of experiments to use phosphogypsum, and they use 40% commercially phosphogypsum. But if compare with the Morocco and Lebanon, only there is discharge the phosphogypsum in the sea. What about Jordan? Jordan, there is stack of phosphogypsum. There is a regulation. There is an experiment for phosphogypsum, but still there is no commercial use of phosphogypsum. So we have to focusing in the near future how to manage phosphogypsum and to be considered phosphogypsum as not waste but a resource. Major ways for phosphogypsum: recycling, production building material, production thermal isolations, component road constructions, paints, calcium chloride, and the fertilizer and the salts. Also, in addition, what I mentioned before, the phosphogypsum can be used in the constructions as the fire resistance for the materials. The phosphogypsum when using in the buildings, low compositable properties is acoustic phosphogypsum, thermal properties good. Also here, as you see from these figures, that the phosphogypsum is a good materials using for the thermal installations in the building. When you gonna go to application BG in the soil as a soil amendment, it carries calcium deep in the soil. It provides nutrients for the plants, reduce aluminum toxicity, helps recover sodic soils, increase water and nutrient absorption. What about the future? Creating customer to export gypsum or phosphogypsum to the world market. You create investment to produce building and cement material like plastic, bricks, pears, calcium powder. Investment in manufactured gypsum-based fertilizer in the world market. Tie up with calcium chloride manufacture and application in the road constructions in Jordan. In the conclusion, BG stacks should stability, durability, coherence, and consistency. BG can be used safely and it is not waste. BG is a vulnerable resource that has a value and a range of well-tested beneficial use. BG has widely used directly as in both agriculture and constructions and also recycled in significant quantities. Stacking is not sustainable options, failing on social, environment, and economic requirements. Thank you for kind attention.
Thank you very much, Dr. Muhammad, for this informative lecture about the activities of phosphate, phosphogypsum and phosphate company, of course. So we have a room for one question. If there is anybody has any inquiry regarding the material presented by Dr. Muhammad, he will be happy to entertain your question. Any? تفضل دكتور وايد.
In Jordan, I mean. Is there any plan for...
Yeah, there is planning now. We are, as I mentioned before, we agreed with the International Center for Agriculture here in Jordan. We signed the OU. to conduct to using or utilization phosphogypsum with the different type of the agriculture materials in different areas, and also as we can be used as a soil amendment to improve the alkaline soil in a huge area in Jordan.
Thank you very much, Dr. Mohammed. I have an inquiry. How about the collaboration and cooperation with the universities regarding the...
The GBMC now has opening to cooperations and collaboration with the universities. And we urged, or hopefully that the researcher from the universities, if they have any research focusing on the phosphate rock and their fertilizer, if there is any problems facing GBMC and any researcher could find the solution for GBMC, we are willing to welcome to visit us, and we can arrange any research, support research or grant research concern this problem. Okay.
I think the magical word is the funding. Thank you very much, Dr. Mohammed, and we will move to the next lecture by, it should be quick, Dr. Salim. We saved the best for the last, so hopefully that can work. ماشي؟ which will be presented by Dr. Salim Al-Sanusi from Libya. Dr. Al-Sanusi is a professor of civil engineering at the University of Benghazi, Libya. He had his PhD from University of Pittsburgh at Pennsylvania, right? University USA, 1990. He will present his talk about prediction of compressive strength of concrete from early age test result using design of experiment RSM. You have 10 minutes, Doctor, so go ahead.
بسم الله الرحمن الرحيم. البيبر تعالج موضوع اللي هو الحصول على مقاومة الخرسانة اللي هي strength for concrete in early ages. طبعا نحن عادة الكونكريت باش تحصل السترينث نتاعها بالكامل ضروري تكون مر عليها 28 يوم. وطبعا هذا في مشاريع كبيرة يحتاج إلى فترة زمنية كبيرة، فنحن بنحصلوا على قوة خرسانة قوية قبل ال 28 يوم. وطبعا مكونات الخرسانة طبعا اللي هي السمنت والاجريجيت سواء الفاين ولا الكورس، بالاضافه الى المياه. طبعا هنستعمل طريقه اللي هي الريسبونس سيرفيس ميثودولوجي. فالابروش اللي هنستعملها في الحصول على مقاومه خرسانه 28 يوم باستعمال الريسبونس سيرفيس ميثود، اللي هو عباره عن كولكشن اوف ماتيريال ماثيماتيكال اند ستاتيكال تكنيكس، يتكون من المعادله اللي هي الاكس 1 والاكس 2 اللي هي عباره عن السيرفيس اللي هي يمثل الاندبندنت فاريبلز اللي هن مكونات الخرسانه اللي هي عباره عن السمنت والماء والاجريجيت. والاي اللي هو عباره عن الايرور في الايكويشنز، ونحن نبغى نتحصل على الواي اللي هو سترينث بالنسبه للكونكريت. طبعا هذا اللي هو تمثيل الريسبونس سيرفيس ميثودز، ممكن عباره عن كونتورز او عباره عن سيرفيسز. Response can be represented by graphically either as in 3 dimensions أو عبارة عن contours. والفirst step في response surface method اللي هو to find suitable approximations for the relations. طبعا هنستعمل second order relations to optimize السترينث اللي بتحصل عليها. وعن طريق الديزاين اوف اكسبيرمنت في الايكويشنز، يعني these stages were originally developed model fitting the physical experiment but can be also applied to numerical experimental اللي هي using اللي هي design of experiment. طبعا هذا الموديل اللي حنستعملوه اللي هو عباره عن الفاريبل اللي هو x1 و x2، ونحن بنحاول على ممكن 3 فاريبلز يعني. طبعا احنا عندنا في الايكويشن في الاكسبيرمنت اللي عندنا عندنا 144 تجربه عند قوه خرسانه لمده 3 ايام واسبوع واسبوعين و28 يوم، وقارناها بالموديل اللي درناه في اليوزنج اللي هو ريسبونس ميثودز. لو this work اللي هو present the maximum examine the maximum mixed proportions اللي هي مكونات الخلطة الخرسانية اللي هي نتحصل منها على الكمبرسيف سترينث بتاع 28 يوم عن طريق الموديل اللي هو درناه، طبعا في أقل من 28 يوم. طبعا عندنا set of data، بعدين نخشيها في الميني تاب اللي هي design of experiment response service method، بعدين define the factorial analysis، بعدين output data processing، بعدين analysis obtained، بعدين ندير عملية optimizations للsolutions. The empirical models are fit to the data and polynomial models اللي هو طبعا نستعمل كوادراتيك في الحالة هذه، نستعمل لك كوادراتيك models في الريسبونس ميثودز. طبعا هذه المكونات الخرسانه اللي هي الفاريبل في الايكويشنز اللي هي يسموا فيها الاندبندنت فاريبل اللي هي الوتر سمنت ريشيو، نسبه الماء الى السمنت، والوتر والسمنت، واللي هو الكورس اجريجيت اللي هي السي اي، والاف اي اللي هي الفاين اجريجيت، وطريقه السترينث اللي هي عند اف برايم سي اللي هو عند قوه خرسانه عند اسبوع وعند 28 يوم. طبعا نحن درناها كاختبار فعلي ودرناه عن طريق المعادله، وتو نشوف النتائج اللي هنا تحصلنا عليهم. طبعا المعادله اللي هي تتكون بها شكل اللي هي عباره عن فيها بارامتر كونستانت وفيها المين افكتس اللي هنا البارامتر الرئيسيه في الخرسانه اللي هي عباره عن السمنت والاجريجيت بنوعيها والمياه. وبالنسبه للبارامتر اللي هي الانتر اكشن اللي هي عباره عن الاكس 1 والاكس 2، والايرور اللي هو عباره عن ابسلون. طبعا احنا اهملناها الايرور في الايكويشنز هنا. لو مشينا لقدام طبعا هذا اللي هو عباره عن الديزايرابيلتي اللي هو في السوليوشنز، يعني حصلت ديزايرابيلتي معينه. طبعا الديزايرابيلتي هو عندنا سيرفيس تايبز اوف ديزايرابيلتي، يعني ممكن الاشكال بتاعها اللي هي ماكسيموم مينيموم والتارجت، هذه اللي ممكن نستعملها. When the model was computed, the test data are used to determine the accuracy of regressions for comparison between the predicted compressive strength اللي متوقعة والtrue compressive strength اللي هو استعملناها بعد 28 يوم. يعني قارناها بين 28 يوم فعلية وقارناها عن طريق المودلز. طبعا طلعنا المين absolute percentage of errors، وطلعنا coefficient of efficiency اللي هو سميه هنا E. لو مشينا طبعا هذه في الموديل رقم 1 اللي هو مكونات الخرسانه الرئيسيه، فطبعا لو انا عوضت باي قيم من الوتر سمنت ريشيو والسمنت والواترز فنقدر نطلع اللي هو كومبرسيف سترينث بعد 28 يوم عن طريق المكونات اللي انا عندي. وهذا استعمال الموديل الاول اللي هو مكون من المين بارامترز او المين اليمنتس اللي هي الووتر والسمنت والاجريجيت بنوعيه. لو دخلنا في الموديل الثاني، هذا الموديل رقم 1، طبعا اللي هو الاكس اكسس اللي هو عباره عن النتائج اللي حصلنا عليها، وعلى الواي اكسس اللي هو عباره عن اللي هي الاكزاكت، يعني اللي هي عن طريق الاختبار الفعلي للمكونات الخرسانه بعد 28 يوم. في الموديل رقم 1. الموديل رقم 2 دخلنا اللي هو قوة خرسانة عند اسبوع بعد 1 ويك، يعني اللي هو الموديل 2 in terms of components of concrete اللي هي strength 7 days. وطلعنا الايكويشن اخرى، فطبعا الايكويشن الثانيه هذه حتطلع اللي هي accuracy اكثر من الاولى لانها دخلنا فيها strength after 7 days. وهي طبعا شوف هذه العلاقه فتلاقي فيه الاكس اكس اللي هو نفس العمليه من الايكويشنز اوكي، والفواي اللي هي عباره عن اللي هو الاكزاكت. وبعدين درنا عمليه اوبتمايزيشنز للداتا، وطبعا السمري كونكلوجنز. لو لاحظنا statistical errors analysis was shown adequate model obtained in this in also that terms added the models have significant effect on the response variable for both models values of E. الافشنسي في الحاله في الموديل الاول كانت 0.85 واللي هي عاليه، ولما دخلنا الاف برايم سي بالنسبه ل 1 ويك فطلعت الافشنسي عاليه اللي هي 0.91، والايرور طلع في الحاله الاولى 6.7% وفي الحاله الثانيه اللي هو طلع اقل اللي هو 4.5% في المودلز. اعتقد شكرا.
Thank you very much, Dr. Salim. I think we have room for 1 or 2 questions regarding the topic of the lecture about statistical analysis, right? Any questions? Okay, anyways, thank you very much, Dr. Salim, for your contribution. And we now move toward our final segment for today's activities and for this conference activities regarding the closure. I leave you with Dr. Zakaria.
شكرا دكتور أحمد. بسم الله الرحمن الرحيم، والصلاة والسلام على سيدنا محمد وعلى آله وصحبه أجمعين. الزملاء dear participants، مع انتهاء أعمال مؤتمر الهندسة الكيميائية الأردني الدولي المدمج التاسع، يسرني أن أقدم التحية والشكر لكل الذين شاركوا في هذا المؤتمر من خلال حضورهم ومشاركتهم بالأبحاث التي ساعدت في إنجاح هذا المؤتمر. ونتقدم بالشكر الجزيل لنقابة المهندسين التي دأبت على دعم هذا المؤتمر والمؤتمرات الأخرى للشعب الأخرى، ونتمنى أن يبقى هذا الدعم ويصبح يعني دعم قوي بحيث ينتج عنه مؤتمرات عالمية فعلا بكل معنى الكلمة. أيضا نوجه الشكر للشركات الصناعية التي دعمت المؤتمر معنويا أولا بحضور عدد من مهندسيها في المؤتمر، وأيضا الشركات التي قدمت الدعم المادي الذي ساعد المؤتمر أيضا في القيام بأنشطته المختلفة. وفي ختام هذا المؤتمر نود أن نسمع منكم إذا كان لديكم بعض الاقتراحات والتي قد تكون تشكل توصيات من أجل عقد المؤتمرات القادمة. فإذا في حد منكم عنده أي اقتراح أو يعني نقطة بحب يحكي لنا إياها، إحنا يعني سعداء بأنه نستمع. هاي المهندس محمد رئيس مجلس الشعبة موجود معنا، وإن شاء الله يعني مجلس الشعبة ومجلس النقابة بيأخذ توصياتنا على محمل الجد ومن أجل تنفيذها بعونه تعالى. احنا عملنا درافت يعني لبعض التوصيات، عملنا درافت لبعض التوصيات اللي ممكن نبني عليها، انه ان يتم عقد المؤتمر العاشر في تشرين الأول من عام 2024 في البتراء. يعني نحاول نغير شكل المؤتمر، نروح يا اما كان في بعض الاقتراح نروح على العقبة يكون او في البتراء. البتراء بسبب سمعتها العالمية وممكن تحقق يعني ناس كثير تفكر نتيجة على المؤتمر زي ما بيقولوا تحقيق هدفين بنفس الرحلة، بحث علمي، تقديم بحث علمي، وأيضا تكون رحلة سياحية. هاي التوصية الأولى. العمل على استقطاب المزيد من الأبحاث من الشركات الصناعية والتي تساهم في تطوير التعاون بين المؤسسات الصناعية والأكاديمية. احنا بهمنا يكون في أبحاث إلا تطبيق في المجال الصناعي، سواء كان في الصناعات الأردنية من حيث البحث والتطوير وتحسين المنتج وحل المشكلات الصناعية. ويمكن لنقابة المهندسين أن تلعب دورا مهما في زيادة التعاون البحثي بين الجامعات والصناعة من خلال دعم بعض المشاريع التطبيقية. يعني النقابة، أنا الاقتراح أنا قدمناه قبل سنة، ويعني كان عندهم رغبة بأنهم يسمعوا التفاصيل، وإحنا إن شاء الله راح نودي لهم تفاصيل بأنه يكون في بعض المشاريع في مهندسين عاطلين على العمل، في دكتور عنده فكرة لمشروع ممكن يطبقوا فكرة في مصنع من خلال دعم مادي من نقابة المهندسين. النقطة الثالثة إنه اعتماد النظام المدمج في كل مؤتمرات النقابة ومؤتمر الهندسة الكيميائية القادم من أجل تسهيل المشاركة الدولية وزيادتها. طبعا يعني هذا النقطة بكرة بيروح كورونا، أنا متأكد إنه نظام المدمج سيبقى، لأنه أصبح يعني جزء من المخلفات الكورونا الإيجابية. إنه واحد موجود في البرازيل ما عندوش إمكانية مثلا يجي يحضر مؤتمر، بيقدر يشارك معنا أونلاين. وإحنا تجربتنا الأولى اللي قدمناها الحمد لله رب العالمين حققنا نجاح إلى حد كبير، بحيث إنه هلا كان عندنا محاضرة وجاهية، قبل كان عندنا محاضرات أونلاين، ويعني الحمد لله رب العالمين جزء تجربتنا يبنى عليها المهندس محمد إن شاء الله عليه. نعم. النقطة الأخيرة العمل على توسيع المشاركة الدولية في المؤتمر عن طريق إيصال دعوة المؤتمر إلى كل دول العالم في المؤتمر العاشر، والتنسيق مع وزارة السياحة من الآن من أجل عمل برامج سياحية للمشاركين، خاصة إذا اتفقنا على أنه يكون المؤتمر يعقد في مدينة البتراء الأثري. هذه النقاط اللي أنا يعني مع بعض الزملاء قعدنا، وإذا في عندكم ونرحب بأي اقتراح وبأي توصية أخرى بتشوفوها مناسبة نضيفها لهاي التوصيات. تفضل مهندس.
شكرا دكتور زكريا. حقيقة يعني باسمي وباسم نقابة المهندسين وشعبة الهندسة الكيميائية نقدم الشكر الجزيل لكل من ساهم وشارك بهذا المؤتمر، ولكم الفخر كاللجنة التحضيرية برئاستك أستاذ دكتور زكريا وزميلنا الدكتور زياد وجميع أعضاء اللجنة أن تفخروا بأنه الجميع بالأردن يتحدث عن هذا المؤتمر، يتحدث عن حجم المشاركة، وخصوصا أنه جاء بعد فترة كورونا وبخاصيته المدمجة اللي أتاحت الفرصة للجميع للمشاركة. وحقيقة ما يميز هذا المؤتمر والحمد لله أولا الترتيب بدقة لكافة التفاصيل من اللجنة التحضيرية، الدعم من مجلس النقابة وزملائنا بالدعم اللوجستي لموضوع انعقاد هذا المؤتمر، إضافة إلى مشاركة من الجامعات الأردنية كطلاب، ومشاركة الصناعة أيضا أعطت إضافة نوعية لهذا المؤتمر خصوصا بالمعرض أو من خلال الجائزة. فأعتقد أنه هذا المؤتمر يسجل في تاريخ نقابة المهندسين، يسجل بأنه هذا الحدث جمع جميع أطياف القطاع الهندسي من أكاديميين وصناعيين وطلبة، لما فيه خير التخصص، لما فيه أملنا في تطوير هذا العلم التطبيقي على المستوى المحلي والمستوى الإقليمي. كل الشكر للجميع، ونراكم إن شاء الله على خير، وكافة التوصيات اللي إن شاء الله رح ناخذها رح نقدمها ونثبتها من خلال الشعبة لمجلس النقابة إن شاء الله للشعبة القادمة إن شاء الله بقوموا بتنفيذها، وأنتم قريبون دائما من النقابة. وهي دعوة للجميع بأنه دورنا إحنا بنقابة المهندسين دائما مفتوحين على الجميع، مفتوحين على الجامعات، على الأكاديميين، من خلال اللجان، من خلال المؤتمرات. في كثير قضايا ممكن إضافتكم أو قربكم لنقابة المهندسين تكونوا added value على العمل النقابي. شكرا لكم جزيلا.
قبل أن أنهي أود أن أقدم الشكر الجزيل لكل أعضاء اللجنة التحضيرية الذين عملوا معنا يعني بكل الأحوال، سواء كانت اجتماعات وجاهية واجتماعات عن بعد. والحقيقة كان العمل يعني لولا العمل بإخلاص من كل أعضاء اللجنة التحضيرية لما وصلنا إلى هذه النقطة. نعم. أسماء اللجنة التحضيرية طبعا الدكتور زكريا القضاء اللي هو أنا الناس الدكتور زياد أبو الرب نائب رئيس اللجنة، الدكتور أحمد الشواكفة البروفيسور أحمد الشواكفة، الدكتور عدنان الحراحشة، الدكتور مروان بطيحة، الدكتور محمد الحراحشة، الدكتور محمد الحويطي، أوكي، الدكتور رياض الشوابكة، الدكتور وعيد عمر، الدكتور عماد القدة، الدكتور حابس الزعبي، الدكتور حسام الخصاونة، الدكتور إبراهيم سليمان، الدكتورة ليندا الحمود، الدكتور نضال حسين، الدكتور عماد المهندس عماد الطلافحة، المهندس خالد عنانزة، المهندس محمد سويسة، المهندس عمر عبادلة، والمهندس روز الصمادي، المهندس يعقوب بني طه، والمهندس إبراهيم إصبيح. لابد من ذكر يعني نقطة، إنه معظم أعضاء اللجنة التحضيرية خلال السنتين طبعا هنا المهندس محمد هو مش لجنة يعني ما قصرت يا المهندس محمد. معظم أعضاء اللجنة التحضيرية ما شاء الله اللي كانوا مشاركين معنا اللي ترقى في الجامعة، في منهم ناس صاروا أستاذ مشارك، وفي منهم صار بروفيسور، وفي منهم صاروا رؤساء أقسام، وفي واحد صار نائب رئيس جامعة، وفي يعني معظمهم يعني الحمد لله رب العالمين تقدموا في المواقع يعني الأكاديمية وحتى البحثية لهم. فهذه يعني يا مهندس محمد مشان المرات الجاية نشجع الناس انه يجوا على اللجنة التحضيرية لانه في عنده امل انه يحسن. احنا بنقول الى اللقاء في المؤتمر القادم ونراكم على خير، والسلام عليكم ورحمة الله وبركاته.